And we are recording. Great. Hello, everyone. Welcome to the Forge Online Bootcamp April 2022 edition. My name is Petr Broz. For those of you who don't know me, I'm one of the Forge developer advocates. So developer advocate means that my role is to help customers leverage our technologies, specifically here focusing on the Autodesk Forge platform. All right, now about the online bootcamp event. We've been running this event for a couple of years now. It's basically aimed at to help developers, external developers who are getting started with the Autodesk Forge platform, and they maybe prefer a more a guided approach rather than just going through some online resources. Maybe there's more, they prefer more interactive, personal approach where you basically follow the tutorials with our help, and we can answer your questions along the way. It's a 4-day event where every day we cover a different topic, meaning typically a different tutorial, one of the official tutorials that we provide, and we also run these webinars in parallel for 2 different programming languages, and we also have an EMEA webinar and an Americas webinar alternative for the different audiences as well. Now, every day, every webinar is split into 4 sessions, where typically each session is basically us going through a part of the tutorial with you following our steps. That's typically roughly 1 hour. And then there's a 30-minute break so that you can catch up or ask questions if you ran into any issues along the way. You can grab a snack, get a coffee or something like that. And then we, after that 30-minute break, we get back together and we continue with the next part of the tutorial. So in total, this should be roughly 6 hours today, including the breaks. And an important thing to note, I know this is something that our attendees often ask, all the webinars, all the different language permutations, and both the EMEA and Americas presentations, all of these will be recorded and made available publicly after the event. We typically upload these videos to YouTube, and we will include the links to these videos in a wrap-up email that we typically send at the end of the event. All right, now the actual schedule for this week. We're going to be, again, looking at a couple of different tutorials every day, where originally we used to use the, some of you may already know, the Learn Forge tutorials that are available on the learnforge.autodesk.io website. But this time we're actually, we've been working on a new set of tutorials, more modern, more cleaned up with fewer dependencies, using more modern JavaScript features and things like that. So for the first 3 days, Monday through Wednesday, we're going to be following these new tutorials. And on Thursday, we're going to be, for the configurator tutorial, we're going to be using the standard Learn Forge content there. For the design automation service, basically. All right, so today, the topic for today is a tutorial we call Simple Viewer. Again, it's available on a new website, a new set of tutorials that we're preparing. You can find a link here, and let me try and see if I can copy. I'm just going to follow the link. And I'm going to send the link to the chat window that you all should have access to, so that you can follow along with me as well. But this is the new website, forge-tutorials.autodesk.io. This is where the new tutorials are available. As you can see, there's 3 tutorials currently: Simple Viewer, Hubs Browser, and Dashboard. And today we're going to be following the Simple Viewer tutorial. And this is a Node.js webinar, right? So in parallel, my colleague is now running a .NET webinar, running through the same tutorial using the .NET programming language. All right. Now, the goal, what we're building today, it's a simple web application leveraging some of the standard Forge components, where basically the web application will allow you to upload designs to Forge, have them translated, converted, prepared for viewing, and then using this simple drop down in the top right corner, allowing you to choose one of these designs that have already been uploaded and converted and preview them in the Forge Viewer JavaScript component. So this is the application that we're going to be building today. Again, allowing you to upload, translate, and preview your designs, whether it's 3D designs or 2D drawings, whether it's AutoCAD drawings or Inventor or Revit or whichever 3ds Max design. Forge today can process over 60 different design formats, not just Autodesk internal ones, but also our competitors. So if you have SolidWorks files or Bentley MicroStation DGN files, all these can be processed with Forge, and all these you would be able to preview using this application that we're going to build today. All right. Today's agenda, again, it's going to be 4 sessions followed by 30-minute breaks. In the first session, we're going to take a look at introduction into well, the event itself, as we just did, and setting up the development environment and making sure that we have everything ready for session 2, where we actually start coding. There are a couple of steps, a couple of things we want to double check before we actually start coding, just to make sure that we are all on the same page, that we all are working with the same version of Node.js, or that that you all have some Forge application credentials prepared, because this is something you're going to need going forward. That's going to be session 1. Session 2, we're going to start with a simple web server, and we're going to implement some basic authentication logic, which is typically one of the first steps you want to do, right? Because when working with Forge or any kind of web service or platform, really, you need some form of authentication, right? You'll need to set up your application so that it can authenticate itself to Forge before we can really start communicating with the different services, uploading files, translating files, or viewing files. That's going to be the task of session 2. In session 3, we're going to start implementing the data management features of our application. So again, being able to upload files, translate them, and maybe list files that we have available in Forge, right? Some files that we will want to, some list that we will want to present to our application's users. And finally, the last session, we're going to put everything together by introducing the client-side component of Forge, which is the Forge Viewer. It's a JavaScript WebGL-based library that can display and load and preview any designs you've processed with Forge. And we're going to add a little bit of user interface, as you saw earlier, just a drop down listing all the files, all the designs that our application's users can view, and a button for uploading and a little bit of HTML markup for uploading files to our application so that you can actually send them to Forge and initiate the conversion process. All right, so session number 1, introduction and setup. As I mentioned earlier, if you want to build your first Forge application, you'll want to create something we call Forge app credentials. And even before that, you also should make sure that you have a Forge account, that you can log in to the Forge developer portal. That would be forge.autodesk.com. You want to have a Forge account so that you can actually start creating your applications, because your Forge apps will be linked to your Forge account. So if you don't have a Forge account ready, you can see I'm already signed in here. You can create a free trial. Let me actually switch to the Forge tutorials website. If you don't have an account, you should see the sign up to try Forge orange button right at the front page of forge.autodesk.com. You know what, let me copy this link into the chat window as well. Oh, wrong one. So this is where you can create a free account and you can start a trial Forge subscription. This basically the way it works is that you get something we call 100 cloud credits. Cloud credits is the currency of Forge that different services, depending on the operations you want to execute in the Forge platform, will consume different amounts of cloud credits. For more information, you can go back to the Forge developer portal, forge.autodesk.com, and you can see the pricing section where we provide more details. You scroll down here, for example, you can see that for something like model derivative API, that's the service we're going to use later today to actually convert the uploaded designs and extract all sorts of information that we can then load into the viewer and show, the properties and model hierarchies and things like that. All that information is extracted using the model derivative service, and that one, for example, costs 0.1 cloud credits for a simple job, meaning everything else, everything but Revit, IFC, or Navisworks files, or 0.5 cloud credits for complex jobs, meaning Revit, IFC, or Navisworks, because these are much more complex and need more processing time. And viewing and everything else, uploading, downloading, all that is actually free. So basically, even if you get, let's say, 100 credits with your trial subscription for Forge, you still get a lot of freedom to experiment with the platform. So if you don't have a Forge account yet, please create one. Again, following the sign up to try Forge orange button on the Forge developer portal. And the second part, as I mentioned, is creating Forge application credentials. So let me show you how that works. Once you have your Forge account created and you log in to forge.autodesk.com, in the top right corner, using your user profile picture, you'll be able to get to a section called My Apps. And go there. I have plenty of applications here already because I work with Forge on a daily basis. And of course, I want to have different credentials, different silos for different projects that I'm working on. Yours might be empty. That's totally fine. What you want to do is use this Create Add button to actually create first Forge application. There are a couple of fields we need to fill in here. Some of these are required. So for now, what I'm going to do is I'm just going to say Forge Online Bootcamp, April 2022, day 1. I'm just going to copy the whole thing into the description as well. Now, callback URL is something that's important for login workflows. That's something that we're going to use on Tuesday, tomorrow, when we actually build an application that will allow our own users to log in with their own Autodesk credentials and access their own data in other Forge-based products. Today, we don't really need anything here, and I don't think that the callback URL, I think it actually is required. So let me just add something like foobar for now. You can always go back and change these values later. I'm gonna use my foobar here as well. And finally, you can select which of the APIs in Forge you would like to use, you're planning to use with this application that you're creating. Now, unless you have any concerns or want to limit the capabilities of a specific application, I don't really think there are any other good reasons for unchecking or disabling any of the APIs. I think I would recommend that you keep everything enabled, even if you're not planning to use, for example, the Autodesk Construction Cloud APIs or the TokenFlex Usage Data API now, because you may want to use them later. So leave everything checked, enabled. All right, I've created my application. Let's see, there we go. So our app has been created, and now the important part is the app that Forge has created for you comes with two values. These are the credentials that we're looking for. They're called client ID and client secret. This is kind of like the username and password of your application, right? This is the username and password that your server app will be using when communicating with Forge, so that Forge knows that who that application is, right? So these are, again, sort of your username and password. So you want to store these. We will use them later when building our application, right? Because again, as soon as our app will want to make a request to Forge to maybe generate an authentication token, or maybe upload a file or initiate file translation, we will always need to authenticate ourselves, our application. So for that, we're going to use these two values. So make sure that you store these somewhere, or you can come back to your application page later. Also, a quick thing here, you don't have to copy and paste the password. You can just double click. You can just double click the password, and it'll automatically get copied into your clipboard. Okay, so all right, I think we're good here. We have our client ID and client secret ready. Okay, move to the next step, which is setting up your development environment, right? So in this case, we're going to be working with Node.js. So one thing I would like you to double check and make sure that we are all, again, on the same page, is make sure that you have Node.js installed, first of all, and that you have, we would recommend using the LTS, the long-term support version, right? So that's, if you follow the link to nodejs.org, the long-term support version currently is 16.14. So make sure that you have at least version 16 installed. And the reason for that is, as I mentioned earlier in our tutorials, we are already using some more modern features, both on the client side as well as on the server side. So we want to make sure that we can use again, advanced features potentially of Node.js on the server side as well. So if you don't have version 16 or newer installed, please make sure that you do it, that you have it installed before we go to session number 2. Now, to try which version you have available, for those of you who are running on a Unix-based system, here I'm on Mac OS, you can just use the terminal and try running node-v. That will tell you the version of Node.js that you currently have installed. Now, if you're on Windows and you install Node.js through this link, you should be able to run the same command from command prompt, right, on Windows systems. Or I would also recommend, if you're not sure which one you should use on Windows systems, I would recommend to install something called Git for Windows. This is basically the Git source code manager that we're also going to be using later this week. And this one, instead of just going straight to Git, I think the official one is gitscm.com. This is the standard. Website for the Git source code manager or management system. Here, in this case, Git for Windows, and again, let me copy and paste this to chat. This one comes with Bash, bundled with Bash as well. So you can then get a terminal-like functionality on Windows as well. I find that more convenient because, again, then the instructions are consistent both on Unix-based system as well as on Windows, right? So if you're not sure, if you want to use command prompt on Windows, that's totally fine. If you're deciding not sure, I would really recommend to try the Git for Windows so that you'll get both Git available on your system, so you can start managing your source code, versioning it, or cloning repositories from github.com, for example. And you get Bash, this terminal-like interface where you can use the exact same commands that we're going to be using here. And again, we try and structure the tutorials so that they work with both terminal and command prompt environments. But again, if you're not sure, I would really recommend using Bash. All right, so in my case, I have Node version 17.5 installed, so that should be good. I could also check version of NPM, that's the Node Package Manager. This is a utility that is, again, usually comes bundled with Node.js itself. It's a package manager that you can use to manage the dependencies of your project, right? You can install more third-party dependencies that maybe your Node.js application will need, or you can use it for other things as well. You can use it to initiate, to scaffold new Node.js projects or package JSON files and things like that. All right, and the other part of our dev environment setup is the code editor. Now, again, here you are free to use whichever code editor you're most comfortable with. So maybe on Windows, maybe you're already using Visual Studio and you prefer that, or using something like WebStorm. That's totally fine. Here, in the Node.js world, typically you run the application from a terminal anyways. So again, if you have other preferences, you're free to use other editors. The instructions here in our tutorial aren't really strictly limited to using Visual Studio Code, as we mentioned here in the slides. But again, if you are not sure which editor you should use, I really recommend checking out Visual Studio Code. For those of you who don't know, Visual Studio Code is this, I typically call it like Visual Studio's smaller brother, younger brother. It's a cross-platform, pretty lightweight editor, really nice one, and especially for web development, I think. Again, it itself is built using web technologies, and it's pretty powerful, and it has some pretty cool functionality. It can be nicely extended. We even built a Forge extension for Visual Studio Code, so that even before you start writing your first line of code, once you have your Forge application's client ID and client secret, you can already experiment with the Forge services through that Forge extension. I may show it to you later if there's some time. So I would again recommend that you install Visual Studio Code. Again, it's available for different platforms. So if you're on Windows, macOS, Linux, Visual Studio Code will be available there. It's free. It's open source. So please make sure that you have Visual Studio Code installed. And again, we recommend using the latest stable version, which is typically what the link provides on the front page. If you go to codevisualstudio.com, I keep forgetting pasting the links to the chat window. All right, I already have Visual Studio Code installed. This is what it looks like. It has a simple interface where you have this, I think this is called the activity bar on the left. You have a file explorer, you can search, you can source control your code, debug, or use extensions. Here, if you search for Forge, somewhere at the top, you should see this extension called Autodesk Forge Tools. This is what it looks like. When you install that extension, I already have it here. You'll get a couple of neat features in the sidebar where you'll be able to view files that were already uploaded to Forge, or you'll be able to upload new files, translate them, query their information, and even preview them directly inside Visual Studio Code. Now maybe let me try. Now, if you install the extension and you run it for the first time, it may ask you for client ID and client secret, because this is typically, let me actually restart. Let me start Visual Studio Code again, because now I think when I try and open it, oh no, okay, so I still have my credentials set up here. When you enable the extension for the first time, it'll ask you for the client ID and client secret, right? Because again, the extension still needs to authenticate itself when it tries to communicate with Forge to maybe get a list of your files or translate them or do whatever else, right? You should be prompted for your client ID and client secret, so you can paste the values there. It'll ask you for some name for the environment, because you can actually have multiple different environments with different credentials set up. So if you have, let's say, 3 different Forge applications, maybe you're working for 3 different clients, right? You can easily switch between the environments here, and then you'll be able to do things like create new buckets, uploading files, translating them, previewing them right from here. All right, that is for VS Code, and I believe that was for the demo. That's it for session number 1. It was pretty fast, so we get a little bit more time now to see if there are any questions, and I see there are 2 actually. So let me go through these. And I remember there was 1 question in the chat. All right. I see a comment. I don't see any links in the chat. Oh, that's a good point. Let me check. Maybe I was sending it. Oh, just to host and panelists. I'm sorry. Thank you for bringing it up. It's awful. All right, so here's what I'm going to do. I'm going to copy the links, all the links that I mentioned earlier. Let me go back to our tutorial. I'm going to copy all these links to everyone in the chat, not just to hosts. All right, this is the link to the tutorial that we're going to be following today. It's called Simple Viewer, and it's one of the new tutorials on the forge-tutorials.autodesk.io website. Then the Forge portal is where you want to create your account if you don't have one yet, and where you'll want to create your Forge application, again, if you don't have one yet. All we need from here is just the client ID and client secret. This is something we're going to need in session number 2 when we start building our server application. So thank you for asking. All right, and then there's a question: should we have the Forge subscription to be able to use the Forge extension? Yes, exactly. You need to have a Forge subscription, because without it, you won't be able to create new Forge app and retrieve the client ID, client secret. And even if you have a Forge application already created, like I have here, and your subscription maybe expires, I believe the subscription is valid for 3 months. After that, you can switch to a paid subscription where you basically buy cloud credits, and I believe the price is roughly equivalent $1 to one cloud credit. So then you can switch to a paid subscription, and you can buy, I think, in 100 increments, right? So for $100, you can buy 100 cloud credits and keep using those, or buy more if you need to. So then, yes, if you get into a situation where you have a Forge application ready, but your subscription is expired, I think you should still be able to use the services that don't consume any cloud credits, right? So things like previewing designs in Forge Viewer, or uploading or downloading, that you should still be able to use. But for the services that do consume cloud credits, like converting your files so that you converting them for the viewer, that may already fail at that point, right? If you have an expired subscription. All right, that was the Q&A, and there was a question in the chat. What happens if our subscription ends after 1 year? Okay, so that's actually, that was the answer. So again, make sure, so I believe that that the trial subscription is valid for 3 months. So make sure that, if you decide to give it a try now, if you create your subscription now, please keep that in mind, that you get those 100 cloud credits that you can start consuming by running different experiments on the platform. But that subscription itself will be available for 3 months. After that, you'd have to switch to a paid subscription. All right, that was for the Q&A, and it looks like there are no other questions. So maybe you can take a quick look at the Forge extension for those of you who maybe are not aware of it. Let's see. So I have my Autodesk Forge extension installed here in Visual Studio Code. And let's say I already went through the process of adding my credentials, client ID and client secret for one of my applications. Here you can see the first section here, buckets and derivatives. This is the standard stuff where, again, you can create, where you typically work with the data management service in Forge. That's the standard service that's used to, as the name suggests, when you manage your data, right? So that service allows you to upload files into something we call buckets. These are sort of like Amazon's S3 buckets, sort of like flat list folders that you can use to organize the content that you manage in Forge. You can create new buckets, upload files, remove them, or and then through this first tree view here, you also get access to the model derivative service in Forge, which is the service responsible for extracting information from your designs. By that we mean extracting things like the actual 3D geometry that you can load in the viewer, by extracting the metadata that maybe is attached to the individual design elements. I'm going to show you quickly what that means, or by extracting logical hierarchies used in your designs that maybe you want to use that information for some custom use cases in the future. All that you can access here in the first tree view through right-click context menus typically, right? So I mean, other than this one, this plus button that I can use to create a new bucket, when a bucket is created, let me see which one would be a good example, maybe here. I can right-click one of these buckets and I can say upload an object, or delete all objects in the bucket, or view details. This is all basically under the hood making HTTP requests to Forge using my client ID and client secret, right? So I only see the buckets that my specific Forge application owns. I don't see any other buckets there, of course. I can request the details. So I can see when this bucket was created, what data retention policy it has, because in the data management service, we also have this concept of data retention policy, where you can choose how long your data should live in that bucket, right? You can say persistent, meaning that the data will remain there forever, or until you decide to remove it yourself. There is also a transient and temporary policy. Transient meaning your data will be automatically cleared after 1 day and after 24 hours, and temporary, I believe, means that your data will be cleared after 30 days. And then, yeah, like once you upload your file, you won't be able to view it yet because your file at that point is just sitting in Forge, but we haven't really extracted any information from it yet. So let me find an example, maybe this one. Plenty of buckets, it's kind of hard to, never sure which one to go to. All right, so here I have a bucket called Petr Broz -samples. Be careful, the buckets, just like in AWS S3 service, they have to be globally unique. So if you try and create a bucket called tests or foo, most likely you will get a 409 conflict response from Forge saying that this global name is already being used by other Forge applications. So keep that in mind. You can see that here I'm trying to generate names that are still short but kind of unique, right? Linked to, let's say, my name. And in this Petr Broz -samples bucket, I already have a couple of files that I had uploaded and translated previously. So what that means is that now I can expand, let's say, which one? Maybe this RAC. This is one of the official Revit sample files. So when I use this arrow next to it, I can actually drill inside that file and see all the outputs that Forge was able to extract from my design, right? So typically there is a one-to-many mapping between the design and the outputs extracted by Forge, because, for example, in case of Revit, I can have, in a single Revit design, I can have multiple 3D views and multiple 2D sheets. And all these will be extracted as separate outputs, right? So in this case, you can see I have two drawings and one 3D file, one 3D view from that Revit design. And then I can actually right-click these and I can say preview derivative, and that will open Forge Viewer right inside Visual Studio Code, because again, VS Code itself is built using web technologies, it's kind of easy to bring other HTML web technologies into it, into the VS Code extensions, right? So here, we're able to actually instantiate Forge Viewer and open the design right here without writing a single line of code, right? And the toolbar at the bottom, this is something that comes bundled with Forge Viewer itself. These are some standard tools that you can use to do things like explode if you want to. Like, this is probably more helpful for manufacturing models. But you can do sectioning, you can do measure, you can take measurements, and what you can start exploring the other types of data that Forge was able to extract from your design. So in this case, in the case of Revit, right, the hierarchy that is typically used in Revit is the families and family types and instances, I think they're called. So that's the logical hierarchy we can see in this model browser panel that is available in Forge Viewer by default, where I can check, let's say, all windows, different types of windows, and then I can actually look at the individual instances and hide everything else. Let me try something else, maybe walls. So there's a curtain wall, a basic wall. Again, you can quite nicely, easily navigate around the model with all this metadata, right? So it's not just the visuals, it's all the metadata that Forge extracts from your design files as well. So you get the hierarchy, and also, let's say if I select this wall, I also get a lot of information about that specific design element, right? So again, this may be the amount and type of properties you see will be different based on the input file format, obviously, but Forge always tries to extract as much information from the input files as possible. In this case of Revit, right, if I select the wall, you can see I have information about the different constraints, structural information, or dimensions, all sorts of things that might be helpful for you again in the future, because it's not just about you being able to view these properties here in some panel in your web application, but you can also query all these properties programmatically using Viewer APIs, as we'll see. That's something we're going to explore on day 3 when we work on the dashboards tutorial, where we're going to be mostly using the Viewer APIs to do all sorts of operations, to query information from the loaded model in the viewer, to change the look and feel of the viewer itself, right? That's where really, I think the greatest power of Forge is, because then you can start adding your own value by, programmatically querying the metadata of your models in the viewer, and maybe, color coding information, the parts of your 3D model based on your custom metric, or inserting custom geometry, overlaying additional, annotations maybe attached to the different elements of your design. All that you can do with the Viewer APIs. That's where you can, start adding your own value, right? You have maybe a custom workflow and a custom use case in mind that no other application is doing. With Forge, you can do that. You can bring your design data at the center and start building the custom user experience around it by customizing the viewer itself using the Viewer APIs. All right, I'll stop here. I see there's one more question, it looks like, in a Q&A. Let's see. All right, there's a question: where do you enter your client ID and client secrets in the Forge Visual Studio Code extension? That's a good question. Let me show you. Let me take VS Code off the screen for a second, because one thing I don't want to do is share my Forge credentials. That's something I recommend you do as well. Do not share the client ID, client secret with anybody else, obviously, because again, this is your application's sort of username and password, right? So this information you should keep private. Now let me delete the credentials and reload Visual Studio Code. Now what's going to happen? See, now I deleted the credentials in VS Code. So now if I try and go to the extension as well, I get a prompt here saying Forge credentials are missing. Configure them in VS Code settings. So one option here you can do is hit the Enter Forge Credentials button. And this is the prompt that I was talking about earlier. This is where VS Code is asking you to enter your client ID and client secret. So what I'm going to do is I'm going to go back to the new application that I created. I'm going to copy client ID, paste it here. Now I'm going to get the client secret and paste it here. Now I can choose which which region I want to, where I want to store my data, right? Forge currently gives us the option to either store physically or all our data in US data centers or in EMEA data centers. I'm going to use US by default, and I'm going to give the environment some name. So maybe I'm going to say Bootcamp. All right. Now our extension environment is ready, but so you can see here at the bottom, Forge Env says Bootcamp, but we won't see any data here, right? Because this is a separate Forge application, not the one I used earlier. This is a separate Forge app with its own set of client ID and client secret. And this one hasn't created any buckets or uploaded any files yet. So I can try it here. And just to demonstrate what I was saying earlier, if I try and create a bucket called, let's say, test, I will most likely get an error. I'm going to choose persistent data retention policy. So data in there, I want to keep them forever. And you can see here, I got a 409 error response from the server, from Forge. I can even check the details, and I may find more information in the response. Here it says, well, it's not that much more information, but we get the 409 conflict error, which means, again, a bucket with this name already exists, and it's owned by other application. So what I can try and do is maybe create a different bucket and call it maybe Petr Broz test. I'm not sure if I have a bucket with that name already. Let's give it a try. Oop, all right. I'd already created a bucket with this name as well. So maybe go even more unique. 2022 test. Oh, wait, now I'm not sure if I can use numbers there. Oh, I can. Good. So be careful about one more thing. There is actually a set of requirements for naming the bucket itself as well. So I think you can only use lowercase letters, underscores, dashes, dots, and numbers. So you may be careful. You may also, if you try and use uppercase, that may not work. You may get an error as well due to these restrictions. All right, so I have my new bucket created, and now it's empty, obviously, but I can start uploading files to it and translating them and previewing them. That is the VS Code extension. So I hope that answers the question. And yeah, we're at 43 minutes in. So I think we can actually get more time for our break. So going back to our presentation here. All right, so now it's 8:44 GMT time on my end. So in roughly 45 minutes, we're gonna regroup and we're gonna move to session number 2. So now is the time. If you have any more questions or comments, I'll stick around for a little more. Then I'm gonna go and grab a cup of coffee. I encourage you to do that as well, or get a snack, go for a quick walk. We all need a little bit of stretch. So I'm going to pause the presentation, and I'll meet you all back here at 9:30 GMT time. So again, roughly that should be roughly in 45 minutes. And I'll be monitoring the Q&A. So again, if you have any questions, ask them away. I'll monitor the Zoom toolbar, and I'll try and answer your questions as soon as possible, again, to make sure that you are all ready to start coding in session number 2. All right, thank you, and I'll see you in 45 minutes. All right, we're back. Thanks for coming back, seeing me here. Let's move to session 2, which, as I mentioned earlier, is about, this is where we start building our first simple server application, and where we're going to implement the first pieces of authentication logic. Now, before we start coding, how does this work? Forge uses this authentication technology called OAuth 2.0 to be more specific. And the way that works is that it's a token-based authentication system, which means that before you can do anything else with that particular service, in this case, the Autodesk Forge platform, you will want to exchange your set of credentials. Remember, that's the client ID and client secret that we generated for our Forge application. And you'll want to send this information to Forge and exchange, receive something called an access token. An access token is this strange long string that has a limited time to live or expiration. It expires in 1 hour. And when you request that token, you can also ask Forge to only enable specific set of actions that the owner of that token can do, right? So you can, for example, say, I want to generate a token that will allow me to upload new files, maybe delete them, or translate them for viewing, right? There are a couple of different operations. They're called scopes that we can take a look at later, perhaps. And then when you talk to the Forge authentication service, you provide your client ID, client secret. The authentication service will generate an access token for you. Again, it's valid for 1 hour, and you can then use that token in your HTTP requests to any other services that you then use. Again, those that the token has the right scopes for, right? The right privileges. That's something called a two-legged authentication. That's what we're going to be using today. Tomorrow, just so you know, tomorrow when we're going to be building a different application that will use a three-legged authentication, which means that it's not just our application and Forge establishing trust between themselves. It's also, there's going to be a third party, and that's the user, where the user will provide their own explicit approval that our Forge application can access the user's data in different Forge-based products. But today we're working with a two-legged authentication, which again means that we will just ask the authentication service to generate a token for us. And then we will be using that token to access other parts of the Forge platform, uploading files, listing files in a bucket, triggering translation of files, etc. All right, now we're moving to the first step of our simple viewer tutorial called application setup. What we're going to do is we're going to create a new Node.js project, and we're going to install some third-party dependencies our project will use. And I'll explain what those are later. We're going to set up the first piece of JavaScript file from Node.js, where we're going to collect the different inputs for our application, right? So our app will need some user-supplied information. In this case, the client ID and client secrets. And we typically provide this information to our Node.js apps through environment variables. So that's what we're going to do here. And then for those of you who have decided to use Visual Studio Code, we'll also create this thing called a launch configuration, which is basically a piece of JSON that tells Visual Studio Code how it should run and debug our application, our server application. So with this launch configuration in Visual Studio Code, we will then be able to run the server app and even debug it, put breakpoints in our server-side Node.js code, step through the code, watch the variables available in that current scope and things like that. And we're going to build a basic server. So we're going to be using a third-party framework called Express, which is a pretty popular server web framework for Node.js. So that's what we're going to be using for our web application today as well. And also what we want to do is at the end, we want to make sure that everything is working as expected. So the new tutorials are structured in a way where at the end of each step, you should always be able to run the application, even though it's not doing much yet. We want to make sure that, even if it's currently, not doing a lot of basic stuff, that it's actually running and that you don't get any errors and that you're ready to move to the next step. All right. And then we're also going to take a look at the authentication step, where we're going to implement the first pieces of logic for our server app, currently specifically the authentication pieces. So we're going to implement the code that will actually send our client ID, client secret to Forge and receive an access token in exchange, so that we can then use the token when communicating with other parts of the Forge platform. And we're going to expose the token that we generate with a custom endpoint as well, because later we will use this token even on our client side for the viewer, because the viewer also needs a token when communicating with Forge. All right, so demo time. Let's take a look at the application setup, right? So we're going to our simple viewer tutorial, application setup step. And we're working with Node.js. So first of all, what you want to do is set up a new Node.js project. Now, you may have different ways of doing that. Me, personally, I prefer to use command line or terminal for that. So I'm hoping that all of you are able to use command prompt or terminal. Or you don't have to. You can create a folder using a file explorer or whatever else. That's really up to you entirely. So I hope that let me maybe increase the font size in my terminal. Let's make sure that everybody can read it right. If you're having troubles with anything I'm presenting here, it's hard to see or something, drop me a note in the chat. Just make sure that I want to make sure that you can follow along easily. So I think the way it works, I mean, if you could maybe take your Zoom window, Zoom call, maybe resize it so that it occupies half of your screen, and then you can put VS Code or terminal on the next side. I'm guessing that might be a good way so that you can actually follow along. You don't have to watch the webinar and then switch over and do something in terminal or in VS Code. So what I'm going to do is I'm going to create a new folder. Up to you, whatever you want to call it. I'm just going to call it simple viewer or simple-viewer. And inside here, I'm going to initialize my Node.js project. This is typically done by running npm init. This would ask you a couple of questions: how you want to name your project, who's the author, what's the GitHub repo, where this project lives, and etc. Here, to keep it quick, I'm just going to add this -y parameter at the end, which means basically answer all these questions with default values. And when we do that, npm, the Node Package Manager, will simply create a package JSON file, which is sort of like the description of your project, the metadata of your project, with these default values, right? Some default version, scripts, license, stuff like that. You can always come back to it later. This is just a JSON file that you can edit whenever you want. And now what I'm going to do is I'm going to open this this folder in my Visual Studio Code. Now there are a couple of ways to do that. You can just open VS Code and just use file open folder, navigate to that folder. Maybe I can do it here just so we're consistent. In my case, I've got my source code in this day one simple viewer folder. Yes, I trust the authors. All right, so open that new folder that you created in Visual Studio Code. Make sure that you're not opening like your parent folder of that, right? So in my case, I created a folder called simple-viewer. So that's what I should see right at the top here with the bold letters, right? Because sometimes people accidentally open like a parent folder of the actual folder that's supposed to be the project folder, and then it's causing issues when they try to use the command line from within Visual Studio Code. To make sure that you open that exact folder where your package JSON file is. So that's what you should see in VS Code now, just a package JSON file with our default values. All right, and okay. Next step is going to be installing dependencies. So in this case, our project is going to use 3 dependencies. It's going to use something called Express, as I mentioned earlier. This is a popular web application framework for Node.js. There are others, popular frameworks as well, but Express is, I think, one of the most popular ones and really easy to use. So for this, you're free to use whichever we want. In our tutorial today, we're going to be using Express. Then we're using another dependency called express formidable. This is because later on in our app, we will want to be able to upload files to Forge through our application, right? And what that means is that our server app will need to handle some special upload requests, right? That may be using some special HTTP content type. So to avoid, so that we don't have to deal with these, low-level HTTP protocol and content type details, we're going to be using this express formidable library to handle the upload for us, right? So we can just easily set up uploading to our server, and then whatever file the user uploads to our application, we can then just send to Forge straight away. And finally, the third dependency, Forge APIs, is the actual official SDK for Forge for Node.js, right? So all the different services in Forge are web services, meaning that you can communicate with them using standard HTTP requests. But then again, we don't want you to have to deal with the low-level details building HTTP requests, including, the encoding, content type, body structure, like the proper structure of the payload, the body of the request. To avoid doing that or having you to deal with all those details, Forge provides SDKs for different, like for the most popular programming languages such as Node.js, .NET, Java, PHP and others, but I think Node.js and .NET are the two most popular languages, and you can find the SDKs for those. And for Node.js, that particular one, the Forge SDK is called Forge-APIs. All right, so let me go back to the command line or terminal. I'm going to type npm install, or you can just type npm e, that's the same thing. -- safe, because we not only want to install these three dependencies or project, we also want to capture these dependencies and their specific version in the package JSON file. That's what the -- safe switch is going to do. It's going to install these dependencies and include them and their specific versions in our package JSON file, so that later when somebody else maybe grabs when we share our source code with somebody else, they can just type npm install, and that command will just find all the dependencies from the package JSON file and install them for them. All right, so we want the express formidable, and Forge APIs. And you can make sure that you are in that project folder that you created. It's up to you how you want to name it. I call it simple-viewer. All right, that's it. Now you can see there is a new folder called Node Modules. That's where all these dependencies and their nested dependencies are stored. And if I look at the package JSON, you'll see that there is now, these dependencies have been captured in the package JSON file, together with their specific versions that, the versions that have actually been installed in our Node Modules folder. This is to make sure that if somebody grabs this code 1 year later, and maybe there are newer versions of Express or Forge APIs, that those newer versions may not work the same way as these dependencies work. That's why the versioning system is included here, so that other person that I share my code with, when they run npm install, it'll install the same compatible versions of the dependencies. All right, so Express Formidable, and Forge APIs are the three dependencies that we want to install. All right, and finally, we'll create a couple of folders in our project folder that we're going to start populating with our code later. There's 3 folders that we want to create. One called www.root. This is where we're going to store all the client-side assets, meaning the HTML, CSS, JavaScript, or images, anything that is going to be used, that's going to be loaded into the browser. Routes and services are 2 folders where we're going to store our server-side logic. Services is where we usually like to store server-side logic that's reused in different parts of the server. And routes are where we usually implement the actual server endpoints, right? So the actual logic that should be executed when somebody makes a specific request to some URL of our server. So let's go back to Visual Studio Code. And here again, you should only see node modules folder with the dependencies and package log and package JSON. The package log is auto-generated. You don't have to worry about that one right now. So here, I'm going to create a new folder, call it www.routes, another folder called routes, and another folder called services. So your folder structure should look like this. Node modules, routes, services, www.routes, and the package JSON file with the log file. That's it. All right. Now the application config. We're going to create a first Node.js JavaScript file, and this one is going to be used to collect all the inputs to our server application that can then be used in different parts of the server app. In this case, we're only going to be collecting Forge client ID, Forge client secret, and an optional Forge bucket environment variable. And this is just so that when we run our application in future, we can either ignore this environment variable and let the app create its own bucket to manage its data in, or we can pass in a specific name of a bucket that maybe already exists that we want our application to use. So what I'm going to do is I'm going to copy this config.js content into a clipboard. You should see this button in the top right corner of every code snippet to get copied into a clipboard. I'm going to go back to VS Code and create a new file in the root of our project folder called config.js. So let's take a quick look at what this code is doing. First of all, we extract a couple of these environment variables from, from the environment, right? And we do that in Node.js through this process.env property, which is a dictionary. So process.env is a dictionary that contains all environment variables available to our process. And this construct here, what we do with the curly braces on the left, this is called destructuring. So we're basically only cherry picking 4 properties from this process.env object, specifically Forge underscore client ID, Forge underscore, these are the actual names of the environment variable that may or may not be available passed to our process, and Forge bucket and port. Now, the first 2 values, right, the client ID, client secret, are required. So if they're not available, we exit the process immediately. We don't start the server at all, right, because these are required. And then Forge bucket, if it's not available, we create a new name for our bucket by simply taking Forge client ID. And remember, I mentioned earlier, the Forge bucket has to be lowercase, right? All the letters in our bucket name. So we lowercase our Forge client ID and we append -basic-app to it. So if whoever is running our application does not provide an environment variable called Forge bucket, we will create a new name for the bucket by taking our client ID to make sure that the bucket name is unique and appending -basic-app to it in this case. And same for port. If port number is not provided, we just use 8080 as the default port that our server will be running on. And then we simply export these 4 values from this config.js file because we're going to be using it in other parts of our server application. All right. And again, if you're using VS Code, we are going to create a launch configuration so that we can later run and debug our server app, our Node.js app, from within Visual Studio Code. Typically, the way it works is that you define these configurations in a file called launch.json in a subfolder in your project called .vscode. You don't have to generate it by hand. Typically, what I do is when you go to VS Code and switch to this run and debug side panel, you'll see that currently there is nothing to run because we haven't specified any launch configuration. And you can see VS Code here is already giving you a hint, right? To customize the section, create a launch JSON file. If I do that, it will ask me what kind of environment, what kind of programming language I want to use to run and debug my app, right? You can see more languages later when you install C# and others into VS Code. For now, I'm just going to use Node.js. There it is. And now if I go back to the file explorer, you can see that Visual Studio Code has created the .vscode folder and the launch JSON file for me. And it even tried and guessed what kind of file I would probably want to run when I debug my app. But here, right now, the only JavaScript file that we have here is config.js, right? So VS Code now thinks that it will run config.js. That's not the case. So we can change this, say, server.js, because eventually we will create a file here called server.js that will be actually the entry point for our server-side application. If I look back, there's one more thing I want to add, and it is this property called Env File. Let me show you what that does. And here, by the way, all the this JSON configuration VS Code gets a nice IntelliSense. So if I start typing double quotes here, I immediately see all the different properties that the launch configuration can have. There is one called Env File, and this is basically a path to a file where Visual Studio Code should read all the different environment variables from and pass them to our application that is being debugged, right? So by default, it suggests to store the environments in a file called .env in our workspace folder. That's here. So that's good. What we're going to do is we're going to create another file here called .env. And this is where you will store or define any environment variables that you want Visual Studio Code to pass to the process of the server application. In our case, we're just gonna take these three, the forge client ID, forge client secret, and optionally forge bucket. Maybe I will exclude it for now. So I'm just gonna take forge client ID, forge client secret. Now the format of the .env file is just name followed by equals followed by the actual value. Now, if there are any special characters, you may want to surround the value by double quotes, but you can actually go without those as well for client ID, client secret. So what I'm going to do is I'm going to go back to the Forge developer portal to grab my client ID. I'm going to paste it here. And again, now what I'm going to do is I'm going to copy my secret here, which again is not something you want to share with others, but for now that's okay for me, because what I'm going to do is after today's tutorial, after today's webinar, I'm going to come back here to my application here. I'm going to use the regenerate button to basically create a new password, new client secret for my Forge application. All right, so for now I just define my Forge client ID, Forge client secret. Again, you can specify a Forge bucket if you already have one that you want to use, or maybe a port number, or maybe in future any other environment variables that you want Visual Studio Code to pass to the process where our server app is running. All right, so now the launch configuration, this one says that we want to run a Node application. We can call it maybe launch server, and we're telling Visual Studio Code that we wanted to run the server.js file, which will eventually exist here. And we want VS Code to read all key value pairs from this .env file and pass them to our process, to the debug process as environment variables. All right, that should work. So now the final piece is implementing the server, right? So right now it's not doing a lot. Let me just copy the server.js content, and again, let's quickly go over what this code is doing. My mouse just froze. All right. So create a new file, server.js. Again, that should be in the root of your project folder, the same place where the package.json, the config.js files are located. Now, what does this code do? First of all, what we do is we import one of the dependencies. Express is the web application framework. This is done in Node.js using the require built-in function. And now we also read one of the the configuration options that we read through from the environment variables, right, in our config.js file. And again, we're using destructuring, and we're only, from all the 4 values exported from this config.js file, we only import the port number. This is where our application, our server app, will be listening on. We create a new instance of our server app simply by calling this Express function that we imported from the Express npm module. And then we set up our app. The Express application object has a couple of methods available on them. Things like listen or use or get or post or on or off. These all are used to set up the different endpoints, or actually there's something called like a stack of middleware that all the requests are being processed by, and all the responses are also going through this stack of different functions that can look for a specific information in a let's say in an HTTP request, such as authentication header, and do something based on that information. With this app.use, we are actually inserting one of the middlewares, Express middlewares, and this one specifically is for serving static files. So imagine with this line of code, app.use, express static, www root, what we're saying is every request that will be made to our server application will go through this static middleware. And that static middleware is going to take a look at the URL of the request that is coming to our server. And it will try and see if that URL path happens to be an actual file somewhere inside this www root folder, right? So if we get a request to something like localhost/image.png or images/logo.png, this middleware is going to try and see if there is a folder inside www root called images, and if it contains a file called logo.png, and if there is one, this middleware will actually skip any other logic that may be below it, and it will immediately respond to the browser who made that request with that logo.png file. That's what this middleware is doing. And finally, app.listen, this is where we initialize our application and make the server listen on a specific port number. So in this case, by default, we're going to be using port 8080. So when we're experimenting with our app in the browser, we will always want to use HTTP localhost:8080. All right, and that's our app. That should be it for the app setup step of our simple viewer tutorial. So now it's time to give it a try. Oh, there is also a quick comment for later. If you want to run your project from, the command line, it's also a good idea to add a script to the package.json file. So that's what we're going to do. If you open the package.json, we can replace this test script because that one is not doing anything, and we can create one called start, and that start script should just simply run a node with our server.js. And I see I actually diverged from the tutorial a little bit, because here we suggest the launch configuration not to run a specific JavaScript file, but to run an npm script called start. Right, so you can notice there is a difference here. In my launch configuration, I'm asking VS Code to run a specific file, in this case, server.js. But here in the tutorial, we're actually suggesting to call npm start instead. That's ultimately Underground is going to do the same thing, but let me just replace the launch configuration with what we have in the tutorial for consistency. So again, this is the same thing. What we're doing is we're asking VS Code to run npm start and to pass in environment variables found in this .env file. And when we run npm start, under the hood, npm will just call node server.js. So it will start our server.js entry point JavaScript file. And that's it. So let's see if that works. We can now, since we've already created a launch configuration, when we go to the run and debug sidebar, we should already see a list of launch configurations. Now there is just one called launch server, so we can give it a try. All right, and now in the debug console, we should see server listening on port 8080, which indicates that yes, our application is now in fact listening on that port and ready to accept our requests. And I see a question here. Could you show us again what we should write in the launch JSON file? I would recommend, just for, again, consistency reasons, to make sure we're all working with the same setup, use the launch JSON content shown in the application setup step of the Simple Viewer tutorial, shown in the application config. So most of this should be generated automatically for you when you create a new launch configuration, but you can just copy the content from the tutorial if you maybe missed that piece. All right, so our app is now running. Let's see if it works. I'm going to open a new tab, and I'm going to go to localhost :8080. And it works. It looks like it may not, but it's actually running. And here the Express application, the server app, is returning this message, cannot get / because we haven't provided any code to be executed when somebody makes a request to our server without any path. The same for if I do something like /foo/bar, the Express server basically says, I don't have any code to run when somebody makes a request with /foo/bar. So this is expected, right? This is already a message coming from the Express server. So that's good. So let me start the app, the debugger in VS Code. And let me go back to the tutorial. We can move to the next step, the authentication. All right. So first of all, some code that will generate the tokens for us, right? As I mentioned earlier, the OAuth access tokens that we then use to communicate with different parts of the Forge platform. Here, what we're going to do is we're going to create a new subfolder under the services folder. We also like to structure the code here to make it nice and clean. So inside the services folder in our code, create another folder called Forge. This is where we can start, implementing any Forge specific functionality that should be then reused in other parts of our server. And here, we're going to create a file called auth.js under the Forge folder. Right, so we have services folder at the top of our project with a Forge subfolder in it, and the Forge subfolder containing a file called auth.js. This is where we can implement all the Forge authentication logic. Now, how's that logic going to look like? That's basically just this snippet of code. Again, let me copy it inside the auth.js file in Visual Studio Code and explain what the code is doing. First of all, we finally import first parts of the Forge SDK. That's the Forge APIs, right? That's the NPM module that we installed. And we're using, again, this destructuring syntax to only bring in a specific class from that NPM module called auth client two-legged. Remember, two-legged authentication, which we're using today, means it's just our application authenticating itself to Forge. There is no user credentials involved. It's just our app and Forge establishing trust between themselves. And then we're, again, grabbing a couple of the input configuration fields from our config.js file, right, which is now 2 folders higher. So we're just grabbing the Forge client ID and client secret. Now you'll notice that we're defining 2 methods, one called get internal token, get public token. Why is that? It's a good practice to generate different access tokens for different use cases, right? Because and especially when working with use cases or applications where you may be using access tokens on both the server side and the client side. But here in this case, we're generating 2 different types of access tokens. One, we call it internal, and one we call public. The public one is, as you can see here, where we are instantiating the auth client class from Forge SDK. We're passing in the list of scopes here. There's just a single scope called viewables read. So basically, we're generating a token that the only thing that this token can do is load some translated file from Forge into the viewer. That's it, right? This is a very limited access token that is fine sharing, sending to the client, right? Because the browser will need an access token for the viewer, right? So for that purpose, we're generating this public token, which is very limited, and it can really do the only thing, and that's just reading, loading a translated file from Forge into the viewer. So even if the worst scenario where this token is somehow that somebody gets access to your browser, the only token that they will be able to steal from you is the one that can load a design into the viewer and nothing else. On the other hand, we're also generating an internal token that has more privileges. As you can see here, this token will be able to do things like get read access to our buckets, get write access. It will be able to create buckets. It'll be able to list files in buckets, create them or overwrite them or create them, right? So this, as you can see, this token is much more powerful. This one we're only going to be using on the server side. So this token will never be exposed to the client, right? So we're here lowering the risk of any accidents or any potential, somebody somehow stealing your token. It's not that that would be easy to do, but again, like if somebody were to get access to your browser and steal an access token, that token will only be valid for 1 hour, and it'll be very limited in what it can do. So this is a good practice, separating tokens for internal operations, which require more privileges, and other operations that maybe can be more limited, such as in our case, the public token only being allowed to load translated files from Forge into the viewer. So that's what we do here. We just create these two helper functions. Both of them do the same thing, right? They just check if the current authentication client and the token, if it's valid, if it's authorized, and if not, we call this authenticate method on it, which is it's an asynchronous method, so we need to use await. And what this authenticate method will do is it will take the client ID, client secret that we've configured, send them to Forge, and receive a new refreshed access token. And then we return the access token by calling get credentials method. And we do the same thing for the public client when requesting the public access token. And both of these methods are then exported or exposed from this module so that we can use them elsewhere in the code. All right, and where we're going to use them is our first server route or router. A router is a concept in Express, in the web application framework. A router is basically an object that can handle a couple of different URL suffixes, and you can then take this router and mount it, quote unquote, to different parts of URLs, even multiple ones, and the router will then be able to handle any URLs coming to a URL created by combining the original mounted path and the path that the router itself can handle. And this is kind of hard to explain, but let me show you on an example. So first of all, we're going to create a file called auth.js in our routes folder. And let me again copy the source code, paste it in VS Code, and explain what it's doing. Right, so in the routes folder, I'm going to create a file called auth.js. I'm going to paste the code from our tutorial. And this is what it looks like, right? So we're creating a new Express router. And on the router, we're adding one piece of logic that the router will be able to, so that the router will be able to handle a specific URL request coming to our server. Here, we're just using /token, but that's not the entire URL. The entire URL will be defined later when we mount the router to our actual server. And in this case, what we're saying is basically our code that will be handling any request to this router will be a synchronous function. What we'll do is we're basically calling the get public token from our services forge OAuth file, right? So that's this get public token. So basically it's just calling the helper function that will generate an access token for public use. And we will return it back to the browser who made the request as a JSON. That's what this response.json means, right? So you can choose to respond to requests to your server in different ways, right? You might want to, I don't know, you might want to send a specific file. You might want to send a raw response to some binary blob, maybe. Here, by calling res.json basically means take whatever the parameter is and send it back to the client who made the request as a JSON file, right? So Express will take care of setting up the HTTP response, content type, content length, all the low-level work, setting up the response object. Express will do for you. You just need to say, I just want to send back a JSON, right? And that's what we're doing here. We're waiting for our asynchronous get public token helper method to generate a token. And then we're sending it back to the client as a JSON. And if there's any problem, if we catch any error, we just call next. That's the third parameter coming to our URL handler. That's basically something that, in the stack of middlewares that I explained earlier, if there's an error, you can actually just call next to let the error go through the other layers, other middlewares in the stack, because maybe there is one that will be able to handle the error. And if not, if none of the middlewares is able to handle the issue, it just goes back to Express, to the server app, and that will respond automatically. It will, I think, send back a 500 error status code with some basic message informing that there's been some sort of an issue that the server was not able to recover from. All right, so this is our first router. Now, if we just run the app again, this router will not be, it'll be floating somewhere in a limbo, right? It's not really attached or mounted to our server application yet. That's the idea of router, that you can create a single instance and you can mount it to different parts of the server to handle different types of URLs. So what we'll need to do is modify our server.js application to actually do the mounting, to mount the router to a specific URL prefix. That's what this highlighted line is doing. So let me just copy this single line and add it to our server.js file. And what we're doing here, we're basically importing the router, right? The router that we export from this auth.js file. We're bringing it into our server.js file, and we are mounting it to this /API/auth prefix. And now we're finally getting to this idea of mounting and combining URLs, right? What this means is whenever somebody makes a request to our server to /API/auth/something, the Express server will try and see if the router can handle that entire path in certain ways. So let's say if somebody makes a request to our server to /API/auth/token, and the request will first go through this middleware that will try and see if API auth/token is maybe a file, and it will find out, no, it's not a file. So the middleware will just ignore this request and let it go to the next one, that next middleware, and that's our router. We will try and see, okay, so the incoming request URL is /API/auth/token. All right, let's see if this router contains a handler for /token, right? So we look at the router, and yes, it does. It handles API/auth/token because we've mounted it to the /API/auth prefix, right? So then it'll execute the logic inside this router endpoint handler, and it'll respond with a JSON. That's it. All right, let's see if that works. We're at the end of the authentication step, and now we're ready to try our application again. Let me run the app. All right, our application is running, listening on port 8080. Go back to our local host 8080. We should still cannot get slash because we still haven't implemented any response for an empty URL. The URL that just goes to localhost 8080 or again foo, right? There is nothing, we haven't written any code to answer that type of URL, but we now have already written some code that should handle requests to /API/auth/something that's in the router. Right, so API/auth/token. And there we go. See, this is a JSON response we received from our Express server from our first endpoint. To prove that this, in fact, is doing what we want is, since we are in a debug mode, right? We have a debugger running attached to our Node.js process. We can put a breakpoint here to, when this router handles the API/auth/token request. And we can make this request again, right? And you see we interrupted the execution here. So if I look at the REQ request object, this is basically an object that Express is passing to our function that contains all the information about the incoming request, right? So you see that, okay, the base URL that this router is attached to is /API/auth. The full URL is the actual, well, /API/auth/token. And maybe there is some body, or there is some, maybe there is some headers, right, coming in with the HTTP request. We can see that here, right? So you can see that whoever made that request to our server is passing in some additional request headers. So we could use this information to see, what kind of user agent they are, for example. And, or, if we were running on different domains, we could find the information here in the request object as well. And it was a GET request, right? All right, and we can step inside the helper, get public token. Here, yeah, we check if the public token is currently authorized, and it is, so we don't need to refresh it. So we just call get credentials. That will actually return the access token object, and we call response.json to send this information back to the client as a JSON object. That's one here. By the way, your JSON response may look different. You may just see a raw, like just text. Here I've installed a JSON parser extension, so Google Chrome. So that's why it's actually, it parses the JSON and makes it, collapsible and formats a little bit more nicely. I forgot the name of the extension. Yeah, it was probably the JSON formatter. So if you Google for Chrome JSON add-in, you should see something like JSON formatter. That's the one I'm using. So we can install it to your Chrome, and then any JSON response you will see in the browser will be automatically, parsed and structured nicely. So that when you get, more complex, more structured data, JSON responses, you'll be able to navigate them nicely. Yeah, this is probably what it looks like without the Chrome extension. All right, and that is it for our session 2. So again, now hopefully you've been able to follow along, and if not, you'll hopefully you'll be able to just initialize the project, install the 3 dependencies. Remember, that's the Express application framework, then the Express formidable. That's a middleware we will use later for handling file uploads, and Forge-APIs. That's the Forge SDK for our Node.js programming language. And creating the config.js file where we collect the inputs for our app, right? That's the environment variables, Forge client ID, Forge client secret, and then the optional Forge bucket. And if you're using Visual Studio Code, also, make sure to create a launch configuration, whether you wanted to run the server.js file with Node or just called npm start. That's up to you. Again, both of these are covered and explained. Well, at least one of these is covered in the application setup in the tutorial, right? Where we explain the launch configuration, what it should look like. So on the tutorial website, we're using the launch configuration that calls npm start. So you can replace that. You can just have your launch configuration run node server.js. That works as well. So make sure that you also make sure that you create the .env file with the environment variables, so that when you debug your app in VS Code, so that VS Code actually can pass these required variables to our process. And finally, create a server.js file with our basic server. That's not really doing anything yet. And then when you run the app and you go to HTTP localhost 8080, you should see that message saying, you know, cannot get slash, because we haven't implemented any logic for that type of request yet. And then the second step that we've just covered is the authentication, right? So we've implemented two helper methods or functions that will generate either an internal token that we can use in our server, or a public token that we can then share with our browser or with our client-side application for the viewer in this case. And finally, we built a router, express router, that handles a single endpoint after being mounted to our app. So in this case, it's going to be the /API/auth/token, and it'll just call one of the helper methods to generate a public token and send it back to the client as a JSON, right? And we mount the router to our server application by calling this app.use and specifying the URL prefix that our router will be mounted to. Okay, and then when you run the app and you go to HTTP localhost 8080/API/auth/token, you should get a response looking like this, right? A JSON file that contains a couple of fields: access token, token type, expires in, expires at. If you see this information, you're good to go. If you see something else, any error like URL not found or any like 500 error or something like that, please drop me a note in the Q&A or in the chat, and I'll try and see what's going on there, because we're going to need this going forward. All right, and we have 7 minutes left for the session slot before the Q&A break. So if there are any questions, let me know now. Otherwise, again, we have 36 minutes so that you can catch up, grab something to drink, go for a quick walk, and then we can meet back here in half an hour and move to session number 3. All right, thank you, and I'll see you in a bit. All right, we're back. Thank you for sticking with me. The session 2 was a bit more involved compared to the intro and the setup. Now I think this is where things get more interesting. Now we're moving to session 3, where we're going to start implementing the data management and the translations for our application, which is again something that's critical before we can show something in the viewer. All right, so this is going to be, now we're moving to this data and derivative step of our tutorial that covers both the data management as well as the translations, or as we call them, the derivatives. So first of all, what we're going to do is we're going to add a couple more helper functions to our services folder, right? So that's where we created this these two functions for generating a public token and generating an internal token. We're going to add a couple more methods functions that we're going to use to, create a new bucket, list all files contained in a specific bucket, or upload a file. And then we're going to add a couple of helper functions for the translations of the derivatives. We call them derivatives because these outputs are all generated by one of the fork services called model derivative service, right? And as I said earlier, this is the service responsible for extracting information, all sorts of information from your designs. 3D models, 2D drawings, metadata, logical hierarchies, or thumbnails, for example. So we're going to add a couple of helper functions for the model derivative service as well. Something that will help us start a new translation job if needed, something that will help us find out the status of an ongoing translation, for example, right? Because the translations may take some time. So we also need to be able to find out what state the translation is in so that we can inform the user, right? For example, if the translation is still in progress, we want to show ultimately some sort of information to the user, like, okay, please wait or try later, the file is still being processed or something like that. And again, we're going to expose this new functionality through a couple of server endpoints, like the one that we added, the /API/auth/token for retrieving the public access token. All right, demo time. Let's go back to our tutorial, data and derivatives. Data and derivatives step. All right, so as I mentioned, we're going to start by adding another file under the services/forge folder. And we're going to call this file, I mean, it's up to you, but here we're going to call it oss.js. OSS is the name we use for the part of data management service that deals with just the simple storage, right? OSS stands for Object Storage Service. So the Forge data management service is multi-layered. It provides this basic simple storage at the bottom, and then on top of that, it also provides some higher level concepts like folder structures and document versions and things like that. But for now, we're just going to use the basic storage service in Forge, where again, we just have a bucket and we can upload files to it, remove files from it, or list the files in a bucket. Okay, so again, and we're at the data and derivative step, Node.js. Let me copy the code, paste it into the oss.js file in our project, and explain what the code is doing. So we need to go to our services Forge subfolder and create a new file there called oss.js. It should sit right next to the auth.js where we keep our token helpers. All right. So what we're doing here is, again, we're bringing in some additional classes for the Forge SDK. And here you can see, this is where we're finally going to use the Forge bucket that we are either getting from the environment variables or that we're generating ourselves by taking your client ID and adding this test app suffix to it. And we're also bringing the internal token helper function, right? Because now we're going to need to start generating tokens that have more privileges, because in this code, we're going to need to be able to get the list of buckets, get list of files, upload files, delete files maybe in the future, right? So the token that we're going to use here needs to have more privileges. So we're not using the public token anymore. That's just used for the viewer that we send to the client. Here we're using the internal token with more capabilities, more privileges. All right. So first of all, we're building this asynchronous helper function called ensure bucket exists, right? This is just something we use in other methods, in other functions, to make sure that the bucket that we want to work with, that we want to upload a file to or list the contents of, that bucket actually exists, right? So what we do is we use the Forge SDK. There's a class called Buckets API. We instantiate it and we call, in this case, a method called getBucketsDetails. That's just used to, just like when I right-clicked on that bucket, right, in the Visual Studio Code extension, this is doing the same thing. It's just making a request to Forge, asking for details about a specific bucket. And if we receive in the response, if the response is a 404 not found, we know, okay, that bucket does not exist. So we try and create it. Otherwise, if the error is different, maybe unauthorized or something else, we rethrow that error from here. But we try and create a bucket. And here you may see that in the payload, the parameters that we're sending in, we're specifying the bucket key, that's the name. And we're specifying policy key, that's the data retention policy that I mentioned earlier. So we're saying that, you can change this if you want. For now, we're just setting the policy to temporary, meaning that, the data that will be uploaded to that bucket will be automatically cleared within 30 days. And we're passing in the token that we actually generate, the internal one, right? So this await get internal token is basically our call to this asynchronous helper function that will get us an internal token with sufficient privileges to actually create a bucket, right? If we tried and use the public token, we would get unauthorized 401 error because that other token is only allowed to view the derivatives, nothing else. Okay, and then we have two functions here, one called list objects and the other one called upload object. Obviously, that's the two parts, the two pieces of functionality that we're going to need for our app that we're building today. List objects, here we just make sure that that bucket that we're working with actually exists. And then we're using another class from the SDK called Objects API. Objects is how we call the actual file sitting in a bucket. So we call get objects in a specific bucket, right? So we say we're using this method call to just get a list of files sitting in a bucket, and you can pass in some additional parameters like, for example, limiting the number of results in a page if you want to get paginated results. So we're saying now we want to get up to 64 results from a bucket, but of course there can be many more files. So then what we do is we collect the response. That's the list of objects. And then while the response includes a field called next, we're actually calling this get objects method again in a while loop, while the response keeps telling us that there is more. Basically, that's the way I guess to describe that, right? So response body, we check if it includes a next property. And if it does, we try and extract some parameter from it called start at. And we pass that start at parameter to the next call to get objects, right? So through that, we can actually retrieve the next page and the next page and the next page. And that way we can actually go through all the pages and return the results, then concatenate it into a single list. An upload object, here we just, in this helper function, we just accept some name of the object that we want to store in the data management service, and an actual path to a file on a local file system that we want to send to Forge. So again, we make sure that the bucket that we want to upload the file to actually exists, and we use the standard FS module. This is one of the standard modules in Node.js for file system operations. So we just call read file sync. This is one of the standard functions to just read the entire file into memory, into a buffer. And then we call, again, using the objects API class, we call upload object. And we specify what bucket the file should be uploaded to, what name it should be stored under. And then we pass in some additional parameters like the size of the file and the actual buffer with the file data. And again, we're using the get internal token here because, of course, to upload a file, we'll need to have a token that has either the data create or data write privileges. And then we simply return the body of the response in case we want to investigate, maybe see any specific information in the response, like let's say something like an object ID, which is something we're going to need in a second. Because when you upload a file to the Forge data management service, the service will generate a unique ID for that file that you can later use when communicating with other Forge services, such as the model derivative service for translations. All right, that's our data management helper. And the second one is going to be the helper set of helper functions for working with the derivatives. So that's going to be a method or a function to trigger a translation of a specific file, meaning to initiate the process of extracting information from a specific design that was uploaded to Forge. And then it's going to be a helper function to get the status of, of a translation. Okay, so let me again, we're going to create another JavaScript file under the services/Forge folder. We're going to call it MD as a model derivative. Let me copy the code. Come back here. Under services Forge folder, create file called md.js and paste the contents from the tutorial website. So again, what we're doing here is, again, we're going to need the internal token, right? So we're bringing in the get internal token helper function from the auth.js file. And we're providing 3 helper functions, one called translate object. This is the function that we can call whenever we want to initiate the conversion of a file. So the process of extracting 3D views and 2D drawings and metadata and thumbnails out of that design. So for that, we're using another class from the Forge SDK called derivatives API. So we create a new instance and we call a method called translate. That's actually the method to initiate the process. It's an asynchronous method, meaning that it'll kick off that translation, but it will return immediately. So we pass in just a couple of parameters for the translation job that we want to start. We're saying what kind of URN. This is the important piece that I'm going to cover in a moment. This is the unique ID of the object that we want to start the conversion for. And we also specify what outputs we want to generate out of this file, because in some cases, Forge allows you to convert your file into different output formats. Like, I think, for example, if you're working with a Revit file, you can output it into a DWG, for example. Let me actually check the table. That might be the best one. If you go to Forge Dev Portal into documentation and to the model derivative service, we'll actually see a list of supported translations. And now again, let me copy and paste this link into the chat window. This is where you'll find the list of all the input file formats that can be processed by the model derivative service and the outputs that can be generated out of it or derived. You'll see that the file formats that are available everywhere are these SVF2 and SVF. These are internal Forge formats used by the viewer, where the SVF2 is a newer, more optimized version of SVF. The acronym stands for streamable viewing format, right? So it's basically a file format that's really easy to send across the internet and load into a browser and load into the viewer. But a couple of input files can also be converted into other outputs. Like in case of Revit documents, you can convert them into DWG or even IFC files. So that's why some of these, again, you have a couple more export options other than the SVF and SVF2. So that's what we're specifying in the job payload, the parameters to our translate method, right? So we're saying that we want to generate SVF files and that we want to export both 2D drawings as well as 3D views. Maybe in some cases you only want to export 2D drawings, in which case you would remove this part and only pass in 2D string to the views array. And we also have a special piece here. We pass in another parameter to our translate object function called root file name. This is an enhancement of this process for special use cases where sometimes it happens that what you want to translate in Forge is not just a single file, but maybe a collection of files, or maybe a complete folder structure with many, many different files nested inside that structure. In that case, what you'll want to do is zip up everything into a zip file, into an archive, upload the archive to Forge, and then ask the model derivative service to take the zip file, decompress it, and start translating a specific file somewhere inside that folder structure, right? So if you imagine, if you're working with Inventor, potentially you can have one or more inventor assembly files, one or more inventor part files or inventor drawing files, and they all reference each other, right? So in that case, it's easier, it's better to zip everything up into a single archive file, send that file to Forge. But then, of course, you need to tell Forge which of the many different files inside the zip should be the entry point for your design, right? So that's where, that's something we call root file name. So we're adding this optional parameter here to our translate object helper function that we can later use to pass in a name of a specific file in a zip file if we are now translating a zip, right? So what we do here, we check if that second parameter is available. And if it is, we modify the input parameters for our translation process to also say that input compressed URN is set to true. With this, we're telling the model derivative service, by the way, this is a zip file, so we will need to decompress it first. And we're also saying, and inside that zip file, there is a specific file with a specific file name that you should take as the entry point into the design data. And then we kick off the translation job and return the body of the response. That's what the translate object is doing. And then the get manifest. Manifest is something that it's a JSON structure that the model derivative service gives you that contains information about all the different derivatives that were found in a design, whether they are still in progress, whether their conversion is still in progress, or whether they were successfully converted, or maybe whether they failed, and if so, why. So it's like a large JSON file. You can, well, actually, I created new Forge app, so I won't have any examples here. Maybe later I'll show you that you can get the manifest details through the VS Code extension as well. So it includes information about, again, like what outputs were generated, how large the outputs are, what was the output of their translation, whether it succeeded or failed, and things like that. So we're gonna add this helper function here so that we can later send the manifest to the client, potentially, or we can use the manifest JSON data to somehow find out whether that design is ready to be viewed, loaded into the viewer, or whether it's still in progress, or whether it failed for any reason. And finally, earnify. This is a weird name, but it's basically URN in the Forge terminology is basically just an ID of a file or an object that is base 64 encoded. So base 64 encoding is something where you can take an arbitrary string or arbitrary array of bytes, even like super general, right? And you can take that data and convert it into lowercase characters, uppercase characters, and numbers. So I think there's totally 64 of these, right? That string is obviously much longer, the base 64 encoded string, but it's safe to be used in different places, such as URLs, right? Because if the original buffer or original string contained slashes, colons, question marks, all those characters are not safe to be used in URLs, right? And that's why we use, in Forge, we use this concept of a URN, which is simply an ID that is base 64 encoded. There are even tools online. If you search for maybe base 64 encode, base 64 encode and decode online, there are even tools that you can use to experiment with the encoding. And let me show, like, let's say that the ID of my object was something. If I encode it, it'll look like this. This is the base 64 encoded version of the ID. This is fine, right? But the problem is, what if the ID of my object was, I don't know, right? Something like this. I have slashes, I have question marks, I have equal signs. If I tried and use this string somewhere in my URL, it would probably confuse the server, right? Because it would think that maybe this is not a name of an object, but maybe that this is still part of the URL path or something like that. So that's where base 64 encoding really helps, because then when I encode this string, it's still just lowercase, uppercase characters and numbers, and maybe question equal sign at the end for padding. And that's it, right? So it's a little bit longer, the string, but it's safe to be used in URLs. That's why we're using this concept of URNs in the code. So here, this earnify function, all it does, it just takes some kind of string and it uses this pretty standard Node.js construct to base 64 encode the ID. And this is something we're going to be using later when we're, implementing a router in our server code that will, need to start a translation of a specific URN, right? Because here, whenever we want to call the translate object function, we will have to provide some sort of ID of the object that we want to translate. And here we already expect a URN. That's the base 64 encoded ID. And the same for whenever we want to request the manifest of a specific object. Here, our helper function already expects a URN. So again, it expects a base 64 encoded object ID. All right, that is for our model derivative helper functions. We go back. Now we're ready to implement another router, express router, right? That's the object that will handle some additional URLs or some additional requests coming to our server application. So under the routes folder, we're going to create a file called models.js. We're going to use this code. It's more complex. So again, let me copy it over and explain what it's doing. So this time we're going to the routes folder. A file called models.js. And we paste our code here. All right, let's take a look and see what this code is doing. So this router will be able to handle 3 different types of requests. A GET request to some sort of a path, a GET request to some sort of a path followed by /URN/status. Here, the column indicates that this is going to be a variable. This is something that can be an arbitrary string. And it's also going to be able to handle post requests this time, not GET requests, but post HTTP requests to some kind of URL. Now let's take a look at those one by one. For the GET request to this, whatever URL our router will be mounted to, what we do is we call our helper function called list objects. That's the one we implemented earlier, if you remember, with the pagination in our OSS file, right? So here, list objects is where we call the GET objects to list contents of a specific bucket. And if there is more, we keep requesting other pages in a while loop, and we collect everything into a single array of all files or all objects. And then once we retrieve the list of all objects in a bucket, we return everything back as a JSON. And what we do here, we're using just this built-in JavaScript method called map that is available on JavaScript arrays, where we map every single object from the array into another type of object. So here O is the input object from the array, and what we're returning is another object with just 2 fields, name and URN. And as a name, we return the object key property from the original list. That's just that's just the property name that Forge returns when we ask for a list of objects in a bucket. So we just rename the field from object key. Instead of object key, we call it name. That's it. And then we provide a URN, right? That's the base 64 encoded ID of our object. And for that, we're using the earnify helper function that we just implemented. Right, so that's for the GET request to some kind of path, right? That will depend on where we mount this router later. And then the other GET request is going to be used when somebody asks not for the list of all files, but maybe for the status of a specific object, right, or a specific file. So here we call the GET manifest a helper function, right? We're already, and this reg.params.urn, that's basically Express's way of retrieving parameters from the request URL, right? So if somebody makes a request to this slash something slash URN status. Using rec.params, we can try and receive that variable part of the path, right? So this can be any base64 string, and we can retrieve it using rec.params.urn. And what we try and do is we try and ask for the manifest, model derivative service manifest for that URN. And if there is one available, we try and basically go through the JSON. So we know, or I know in this case, that the manifest, you could actually, you could print it out into a console or put a breakpoint here to explore what the manifest object looks like. It's just a JSON structure. We know that at the top, it has a property called derivatives, which is a list of all the different derivatives that the service was able to extract out of your design, whether they are, again, 3D geometries, 3D views, 2D drawings, thumbnails, everything. And from what we do there is we go through every single one of these derivatives, and we collect any kind of messages that might be there, that might be defined on that derivative, right? There might be some warnings, there might be some errors. So we keep this list of messages that we collect from all the derivatives. And then if that derivative has any children, we recursively go into these children and we collect messages from there as well. So all this code is doing, it may look kind of weird, but all this code is doing is just drilling into the JSON manifest structure and looking for any warning or error messages that the model derivative service may have stored there to let us know that maybe something went wrong, or something like that. And then once we've collected all the potential messages from our manifest JSON, we respond back to the request with, again, a JSON telling, reporting the status of the translation, because we know that that's going to be stored in a property called status of the manifest itself, progress of the conversion, and any warning or error messages. But if we don't get any manifest as a result from this get manifest helper function, we simply return a JSON saying status not available, meaning that probably, most likely, no translation has been started for this file yet. Okay, so this is for getting the status of a translation. And finally, a post request. In HTTP, there are different verbs that you can use for request: get, post, patch, delete, head, and others. Post is typically used when you want to create a new resource somewhere in some web service that you're communicating with. And here we're going to use it for the same thing, basically. In our case, whenever somebody makes a post request to our server, we will assume that someone wants to upload a file and send it to Forge and start and initiate its translation, actually. And here, this is where we are finally using the express formidable NPM dependency that we were looking at in the first session, right? If you remember, I was mentioning that express formidable is an express middleware that can handle requests with file uploads, because again, uploading a file through an HTTP request requires some setup. You need to set up the proper content type, the encoding, and the proper content length and things like that. And then also when retrieving that file on the server side, it takes some work. So to make sure that you don't have to worry about that, we're using this express formidable dependency. And we are, you can see this is kind of strange, right? Because typically when we're writing any router endpoints, we just, the parameters to the router get function is typically just some path or prefix or suffix, followed by a function that should be called when a request is made to that URL, right? The same here. When somebody, I just have some kind of a path or part of a path and a function that should be called. But here, we actually have more parameters. See, we have a string with a part of a path, and then we are calling this formidable as if it were a function, and then we are passing in a function that contains our code that should react to this request. This is because you can pass in additional middlewares for a specific verb, and specific path. So here we're basically saying whenever we get an incoming request, which is a post request, so some kind of path, we want that request to first go through some middleware, in this case, through this express formidable middleware, which may do something on the request. It may try and read some information. It may create another properties on the REQ object, or it may respond with an error immediately so that our code is never called, right? So this is another middleware that will get put on the stack that will be handling any post requests to this specific path. And what this formidable middleware will do is it will look if the incoming request is a post request, if it has like some specific content type, that's if it maybe contains any file that's being uploaded. And if so, it will store the file in a temporary local folder for us so that we can, we don't have to worry about understanding the HTTP request. We will already have a file sitting somewhere in a temporary folder ready to be used. So what we do, because here you can see inside our helper, inside our endpoint handler function, we are trying to access this request.files property. This files property is not typically available on request objects. This will only be available here because of the formidable middleware. So what we do is we try and check, okay, we are expecting this incoming request to include a file called model file. Let's see if it exists. If not, respond back with 400, which typically indicates some sort of client error, the 400 response, and we say the required field or file, model file, is missing. But if it is available, what we're going to do is we're going to take the name of that file and the path. Path is going to be the file path somewhere on our server, local file system where the formidable middleware has stored the uploaded file. So we're going to send it to Forge using our upload object helper function. And when that's ready, we're going to call the other helper function, translate object, to actually initiate the process of the conversion, right? So as soon as the file is uploaded to one of our buckets, we initiate the translation process for it. And then we again respond with JSON, telling the user, okay, your file has been uploaded and is now being translated. This is the name of the file under which you will find it in a bucket. And this is the URN, the base64 ID of the object that you can use later to actually load the file into the viewer. That's it. So we've built our models router. Now, again, just like with the authentication router, we need to mount it to our server application. And then once again, we do that simply by adding this app.use line to our server.js file. Copy this line. Let's go to server.js and it's here, right? So again, here we're building the stack of middlewares for our server application so that when an incoming request is not handled by the static file server, if it's not handled by anything /API/auth, if it's not handled by any endpoints in this router, it will fall further down through the stack. And then it'll, maybe if the request is /API/models, we will try and see if that GET request can /API/models can be handled by this router. And in this case, it will be able to, because /API/models with nothing else behind it, that's basically what this function handles, right? So in this case, if somebody makes a request to /API/models, we just return a list of objects. And if somebody makes a request to /API/models/ base64 encoded URN /status, that request will be handled by this logic. All right, that's it. So now let's see, let's run our application. It's listening on port 8080. So we can go back to the browser and try localhost 8080. Cannot get / because we still haven't implemented anything for this URL, this empty URL. But now if I go to API models, see, okay, and we get a response which is not super exciting. It's a JSON response with an empty list, right? Because now I'm using a new bucket with where I haven't uploaded any files to yet. Now, to see if this really works, what I can do is I can go back to my extension, because we will be able to test the upload later, right? When we implement the viewer and the UI piece. But even now, just to make sure that everything is working as expected, what we can do is can go to our bucket. This is the one that I'm using in my that I'm going to be using in my application. Or actually, wait, I just realized that. Oh no, okay, I'm going to be using a different one because I haven't configured the Forge bucket environment variable, right, in my app. And what that means is that since I haven't specified Forge bucket, this Forge application has automatically created a bucket called my client ID followed by -basic -app. So I can now see this bucket here. This is my application's client ID followed by -basic -app. So what I'm going to do is, since I know that this is the bucket that my app is working with, I'm just going to right click it and I'm going to say upload object. And I'm going to try and see if I have any sample files I could use. Maybe, I don't know, an IFC file. No, maybe just a Revit file. All right, let's try this one. Yeah, 18 megs. Now I can choose how I want to name that file in my bucket. So I'm just going to keep the original file name. And that's it. Now my file is being uploaded. And by the way, while we're on this topic, Forge also provides a resumable upload feature. That means that you can sort of initiate a session that you can use to, you can upload your file in chunks within that particular session. And that means that if for any reason, maybe your internet connection drops, or if your user decides to cancel the upload and maybe try it again later, you can actually resume. You don't have to, you can find out in that upload session which chunks have already been uploaded, and then you can just follow up with, the chunks that are missing. All right. Let's see. And the file has been uploaded. You can see that now the Visual Studio Code extension is already offering me to start the translation of the file, but I'm not going to do that yet. Now, okay, so you can see here that our file already exists, right? It's in our bucket, but if I try and look at its derivatives, it says no derivatives yet, right? Because now what the extension did is it asked the model derivative service for the manifest for this file, and it found out that there is actually no manifest, meaning that no translation work has been triggered for this file yet. And it's fine, we can do that later. But the reason I wanted to upload this file by hand is so that I can run my server again. And if I repeat this request to /API/models, I should now see the file there. And indeed, I can see it here, right? So you can see this is the name of the file that I uploaded to the bucket. And this is the base64 encoded ID of that file. Now let's try something. If you remember, the other endpoint that we implemented in the router was this something /URN/status, right? So let's try that here. API models /URN, that's this long, weird base64 encoded string, /status. And it works. See, this is the custom JSON we're getting back from our server telling us, oh, okay, not available, right? The model derivative service does not have any manifest for this URN, meaning that most likely no translation job has been triggered for it. Okay, so that should be it for session number 3. Yes. So let me first check if there are any questions. All right, there's a question. How do you specify several formats desired? So I'm guessing that means if you wanted to generate multiple outputs with OBJ and IFC, maybe an SVF. We go back to our model derivative helper functions. That's actually here. You can see that, I mean, this job input is kind of chatty, verbose, right? You can find all this information in the reference. Let me find that. Go to documentation, model derivative service. And for example, if we try and find the post job endpoint, this is the HTTP request that the Forge SDK actually calls when you call, when you say translate something. It makes a request to this URL to developer API autodesk.com/model derivative v2/design data/job. Here you can also find some additional information on like what are the required request headers, right? And these are required, but you don't have to worry about these because the Forge SDK takes care of that for you. But it also talks about the structure of the body of the request. So here you can see that, okay, there must be an input parameter and an output parameter. That's what we're specifying here, right? In our job payload when we're calling the translate method. And the input must have a URN, which is the base64 encoded ID of the object we want to translate. And then there are these are the two optional parameters that we're only in setting when we know that somebody wants to translate a zip file. And in the output formats, that's what we're specifying here, output formats. Let me maybe some separate lines. There's the formats list that this is where you can actually specify the multiple outputs that you want to generate, right? So in our case, we're only requesting a single output that is the SVF format. But here we could have multiple, right? We could have a DWG, right? Or an IFC or others. But here we're only interested in generating the SVF output. That's the streaming viewable format. That's the format that Forge Viewer can load. And that's what we're going to do in session number 4. So I hope that answers that question. And with that, we still have 15 minutes left and a 30-minute break. So that's again giving us 45 minutes to catch up, ask any additional questions, grab a snack, go for a quick walk, and then we'll be back for the final session, session 4, where we're gonna implement some basic UI, and we're gonna finally use the viewer to bring the translation output into our web app. All right, so thank you very much, and I'll see you back here in 45 minutes. All right, we're recording. Hi, everyone. Welcome back for the 4th and final session of the training today. This is the final step, is where we take all the pieces that we've implemented in the previous sessions, and we put everything together in the front end piece with a little bit of HTML markup and Forge Viewer really occupying most of the real estate, giving us the option to see objects available in the Forge maintained bucket, and selecting one of these files, loading them into the viewer, or uploading it and translating a new file. All right. So this is the final part of the simple viewer tutorial named Viewer and UI. So here's what we're going to do. We're going to add client-side JavaScript logic for the viewer, right? This is the code that we're going to use to load a specific design, specific URN, and some specific output of that URN, right? One of the default viewable, basically. And then we're going to add a little bit of JavaScript logic for the actual application, right? So JavaScript logic to handle the populating the dropdown and handling the dropdown selection event, and setting up the upload procedure for the upload button as well. And finally, we're going to expose all of this in a simple HTML page with a little bit of CSS styling. All right, well, let's get started. We're going to the viewer and UI part of our simple viewer tutorial. Like I said, we're going to start by adding a little bit of viewer logic. So in the www root folder that we created in the first step, in the first session, this is where we're going to define all the client-side assets, JavaScript, CSS, HTML, images, everything. And it's also the folder that the Express middleware is serving all the static files from, if you remember. What we're going to do is we're going to start by creating a viewer.js file in the www root folder and prepare a couple of helper functions that we're going to use for the viewer itself. There are, as you can see here, we're going to build a function that will retrieve an access token for the viewer. And if you remember, this was the first server endpoint, excuse me, that we've implemented, API/auth/token, right? And the response to this request will be the JSON with a couple of fields, including access data, access token, expires in, expires at, and things like that. So this is a function that our viewer will actually need in order to be able to communicate with Forge, right? The viewer will need to provide an access token that is actually valid and that provides access to the derivative data owned by our Forge application credentials. So you'll see later that this get access token function is going to be used when initializing the viewer itself. That's actually the second helper function called init viewer that we export from this JavaScript file that we're going to use when initializing the application itself. This helper function, it returns a promise, and it's initializing the viewer itself. And it's setting up some default things like that, some viewer extensions, and it's initializing the viewer in a specified HTML element as a container. That's typically a div or a similar HTML tag to where the viewer is hosted. And we start the viewer and set some default theme. That's really all that there is for the initialization of the viewer. And finally, we're going to export a helper function from this viewer.js file that will load a specific model with a specific URN into the viewer, right? So here we are again using some of the functionality from the Autodesk.viewing namespace. This namespace is made available in the code by importing a JavaScript file for the viewer itself. And we're going to see that at the end in the HTML piece. Okay. So what we do here is we call this static document.load method, loading a specific URN from the model derivative service. This is actually loading the manifest that we discussed in the previous session. And depending on whether the operation succeeds or fails, we either load one of the default viewable for the URN. And again, remember that for a single URN, meaning a single input file, there might be multiple outputs, multiple different 3D views, multiple different 2D sheets or 2D drawings. So here, instead of complicating things by adding another dropdown, we just load the default one. We just go through the manifest, we find the default output, the default derivative, and we load it into the viewer using this viewer.loadDocument node method. And if the document manifest loading fails, we reject the promise so that we can react to it appropriately in the application itself. All right, so let me copy this code, go back to Visual Studio Code, and let's go to the www root folder and create a file there called viewer.js. This is it now. Now you may have noticed that I'm using the export keyword here. That's because in these new modern tutorials, we're actually now using something called ES6 modules. That's relatively new, not that new anymore, but relatively new feature of client-side JavaScript, where instead of you having to include every single client-side JavaScript file in the HTML, you can actually just include one of them, let's say like an entry point JavaScript file, and then that JavaScript file can import other JavaScript files as ES6 modules into it. So that's the syntax that we're actually using here. That's what these export keywords are for, right? So this file is eventually going to become an ES6 module, an ECMAScript 6 module that we can import into other modules, and we can only import selected symbols that we want. So here we're exporting two functions, and later we can decide which of these we want to import into other JavaScript modules. And the other thing you may have noticed here is this strange / comment at the top. This is a pretty neat thing if your work that's specific to Visual Studio Code. If you're working with Visual Studio Code, the editor allows you to install TypeScript definitions for different client-side libraries, and it can then provide some nice IntelliSense for these. So what that means is, right now I don't have this npm module at types for viewer installed, but if I did have this npm module installed, the Visual Studio Code would actually provide IntelliSense for these Autodesk.viewing namespace classes and methods and everything. So that's pretty useful, because right now, if I try and say, okay, create a new instance of Autodesk viewing GUI viewer, it's just, Visual Studio Code right now cannot really guess or infer any kind of type or type information on this object, right? It just thinks, okay, it looks like a class, that's it. So here I don't really get any more details about what this object is, what the type of that object is, and what methods it has available on it, right? We don't know, because it's just client-side JavaScript. It could be anything. But then if I were to install that additional dependency, so let me just copy it, go to the terminal and type npm install. Maybe I'll save it as a developer dependency. See, okay, it's been installed. We double check. All right, so see, it's been added to our, not to usual dependencies, because dependencies are usually things that your application requires to run, to actually be runnable somewhere, right, on a different system. But then dev dependencies are those that are not really needed to run an app, but those are helpful for developing, like modifying the code, working with the code, right? So that's why I put this module at type /ForgeViewer into dev dependencies. I did that by adding not --save, but --save that -dev flag to the npm install command. And now check what'll happen. So now, since we have this comment, this import here, Visual Studio will actually try and see if that module is available, installed, and it is. And it'll actually find all the TypeScript definitions interfaces for the ForgeViewer class and all the related JavaScript classes. So now let's see, if I hover the GUI viewer 3D class, you can see that now it's not saying any anymore. It's now saying, okay, well, this is an actual class called Autodesk.viewing.GUI viewer 3D. And it's already telling us, for example, the types of parameters that the constructor can accept, or it can tell us more information about the individual methods. So here, if I type in viewer dot, you can already see different methods available on the ForgeViewer object, which I think is tremendously useful, especially later on when you start working with the viewer APIs a lot, right? These are the viewer APIs. These are the different methods you can use to customize the viewer experience, right? To control the state of the viewer, to read information about the model from the viewer and things like that. So I think this is really, really cool. This works again in VS Code. I'm not sure about other editors. It's really nice when the when the editor tries to do more type inferring up, but getting more information about the types so that it can help you more with IntelliSense and things like that. All right, so this is our collection of helper functions related to the viewer, right? We're not including the viewer.js file anywhere just yet. We're going to do that later. All right, now the application logic. We're going to create another file under the www root folder. We're going to call it main.js. And this is where we're going to set up the application itself. So let me copy the code again and explain what it does. So go to the www root folder, create a file called main.js with the content of that script. All right, so see here, you can already notice this is the ECMAScript 6 modules syntax where we don't have to, include that viewer JavaScript file somewhere in the HTML. No, now we're simply importing this JavaScript file into this JavaScript file, and we're cherry picking which parts of the module we want to import, right? We're importing the init viewer method for initializing the Forge viewer and a load model helper function for loading a default derivative of a specific URN into the viewer. And here what we do is we start by initializing the viewer itself into a predefined HTML element. That's something we're going to create in at the end when we add the HTML piece. There's going to be a div container, div element named preview. So we're basically initializing the viewer inside this div element. And when the viewer is initialized, we just do a couple of things. We try and check if there is any URN appended as a hash fragment to our URL, right? So in the URL, you can have query parameters following the question mark. And you can also have this, like, it's called, I believe, hash fragment after the hash sign. So here what we're doing is we're actually looking at the URL that's currently open in the browser, and we're trying to see if there's any hash part to the URL, anything after the hash symbol. And if there is, we're going to basically use that information to immediately load that specific URL into the viewer. So this is something that's going to be helpful later when we maybe want to deploy our application and share a link to this app with someone, right? We don't need to just send them the link to the app itself. We can also include the hash sign and the URN of, let's say, a specific design that the viewer should open for them automatically, so that they don't have to click on your link and open the dropdown and start looking for the model that they want to load. And we also, when the viewer is initialized, we set up the UI for model selection, that's the dropdown, and we set up the model upload, that's going to be the button next to the dropdown that we can click to initiate the upload. Now, model selection setup, what exactly it does, we just grab an existing element in the HTML markup. So again, the HTML markup is going to have a file called, a select element called models. And what we do is we clear the contents of that HTML piece. And we ask our server, we make a GET request to this API/models. And again, if you remember, this is the endpoint where we go through all the pages, where we list all the files in our bucket. We collect all the pages into a single flat list of objects and return a JSON with their names and URNs. So fetch is a built-in client-side method for making requests to server sides. So here we just ask our own server for the list of files that the application has stored in its bucket. We convert the response into a JSON, and then we basically map the JSON response into a new HTML markup here, right? So we map every single item in the models list into an option HTML tag. And then we join all these strings and insert them into the HTML dropdown. So this is basically manipulating the HTML programmatically using JavaScript. So we're going to get a list of objects, turn that list of objects into this list of these option HTML tags, and then we connect them using new line and we insert them into the HTML. So they will become available as new values inside the dropdown. And then we also set up this on-change event handler on the HTML select element, so that when somebody selects any other item from the dropdown, we react to it, right? And we react to it by calling onModelSelected. That's going to be implemented later. All right. And if there's any error when requesting the list of objects from our server side, we show an alert and we print all the details about the error into the browser console. That's for setting up the dropdown. Then for setting up the upload button, there's a little bit more code. And the way it works is that there's a common procedure when handling uploads from programmatically using JavaScript. The way it typically works is that you have an upload button and you have an HTML input tag that can be used to select files. This is typically used in HTML forms when you want to fill out a form and maybe attach a file to the form that's eventually going to be submitted to the server. So this is going to be this input get element by ID, where we're looking for an HTML tag with the ID input. That's going to be an HTML input element with a type file, meaning that that's an form input field that expects a file to be attached to it. All right, and what we're doing is basically upload on click. That's the button. That's going to be the HTML button. We implement the on click handler by basically emulating a click on the file input form element. So it's a bit strange, but this is, instead of showing like a larger form field HTML markup that shows choose your file and a button next to it, we just show our own button that's just going to say something like upload, and we hide the actual file input HTML element right next to it. And again, this is going to be more clear when we look at the HTML markup. And here when we click on the button that we insert, that we have in the HTML, we're just going to emulate as if user clicked on the file input HTML tag. And again, when that file input HTML tag detects any sort of change, that's when we can actually trigger our uploading process to the server. So what we do is we take the HTML input element, we grab the first file, and we start building form data. This is, again, a built-in class in the client-side JavaScript that is used to send form requests to servers. So what we do is we create a new instance of this form data class, and we start appending parameters like fields to it. One of them is the model file. If you remember, this is where our server side will expect the actual content of the file that we're uploading to be provided, right? So that's what we do here. We also check if the file that was selected by the user before the upload, if that file ends with .zip, and if it does, we show a prompt asking the user to specify which file inside the zip archive is actually the entry point for our design. And then if that is confirmed, we include the entry point file inside the archive as another field to our form data, right? So in this case, we call it model zip entry point. And just to show why we, again, how you name these fields, that's totally up to you, but this is just because in the post URL, the post endpoint handler, right, we are expecting the file itself to come in a field called model file. That's what we do here by appending file object to a field called model file. And this optional one that we're looking at is the model zip entry point, right? So this is an optional field in the incoming form data that may be included only in case we're uploading a zip file. So that's what we're doing here, where we're specifying which file inside the zip archive is the entry point for where the translation should begin, basically. And then what we do is we disable the upload button and the dropdown for the process of the uploading. and we start the upload. So you can see here, we're using the built-in fetch method again, but this time we're passing in a second parameter with some additional options. So this time we're again making a request to API/models, but this time we're not making a get request. We don't want to get a list of models. We want to make a post request. We want to upload a file, right? So that's why we're passing in the form data object as a body of that request. All right, we wait for the response, and the response should basically give us the information about the uploaded object, which should include things like the URN, the object name, bucket name, and everything. And once that is done, we call the setup model selection method again. So basically what that means is that when we upload a new file and the upload finishes, we refresh the dropdown by calling the setup model selection again, right? Because this method, this function clears the HTML of the dropdown, and it requests new list of models, and it generates new set of options in the dropdown for it. So this is a way for basically refreshing the dropdown after uploading a new file. That's what we do here. And if there's any error, we again report the error to the user through an alert, and we report details into the console. And either way, we use like a simple notification where you just show an overlay over the viewer canvas with some additional information. Like in this case, we're just showing, okay, we're uploading the file. Do not reload the page, right? Because the process of uploading the file to our server may take a while. So if the user wanted to reload the web page while the upload is in progress, the upload would be interrupted, unfortunately. So we just show a simple notification informing the user that, please wait, the model is being uploaded. And then at the end, we clear the notification and we re-enable the upload button and the dropdown again. That's what's happening for the click on the upload button. All right, and finally, what do we do when a model is selected in the dropdown, right? What we do here is, first of all, we take the URN that we're being asked to load into the viewer, and we set it as the hash fragment of our URL in the browser address. This is just a little convenience feature where when we select a specific model, we store the selection in the URL address in our browser so that we can then, if we wanted to copy and paste that link and send it to someone, they will get the URL with the loaded model URN included, right? And following that link will basically open the same model for them immediately. So this is just, again, like a little link sharing convenience feature. Now, what we do if somebody calls this method, if somebody asks us to load a model into the viewer, first we check the status, right? So if you remember, this is another endpoint that we implemented on the server side that will return information about the specific model and its translation in force, right? Whether it succeeded, whether it's still in progress, whether it failed. And it's the one where we go through all the children and we look for any warning or error messages that we could also report back to the client. We do that and we check, and again, it's a JSON response, right? And we check the status of the response. If it says NA, if you remember, not available, that means the manifest hasn't been found. No manifest has been found for this URN. In that case, we just, again, show a notification informing the user that the model hasn't been translated. If the status is in progress, we let the user know that the model is being translated. Maybe it'll include a percentage information, like how far the translation is. And here we schedule like a refresh here in 5 seconds. Sorry, yeah, in 5 seconds we basically schedule. We use this built-in set timeout function. It's another built-in JavaScript thing. This is something that can be used to schedule a function to be called later at in a specific number of seconds or milliseconds. So here we're saying in 5 seconds, call the same function again, right? Meaning in 5 seconds, try to load this model again, just in case it's still in progress. Now, if the status of the translation is failure, we report the messages, any messages we've been able to find in the manifest, we report them to the user. We just say translation failed, and we show, in the notification, we also include the messages themselves. And finally, a default branch of this switch statement means that the status is success, in which case we can load the model, right? And this is where we're calling the helper function from viewer.js load model, where we grab the default derivative and we load it into the viewer. And that's pretty much it, right? The final two functions are just for the notifications. Show a notification will just grab an existing HTML element in the markup called overlay. It will set its content to whatever message we want to display to the user. And clear notification will just clear up any content of that overlay. And it hides the overlay as well by manipulating the CSS style. That's it. So that's for our main application logic, right? So we've now set up the dropdown populating and the dropdown selection and the upload button, the upload process. And also this automated refreshing if somebody selects a file from the dropdown and maybe that file is still being processed. Right. So then we move on to this, just the styles and the HTML. That's really where we wrap up the client-side piece, right? So the markup, client-side markup is pretty simple. It's going to be a file in the www roots folder called index.html. So let me again copy it. Create new file index.html and bring the markup here. So as you can see, this is really simple. Let's just take a quick look at what we're doing here. In the head of the markup, we're adding a style sheet from developer API Autodesk.com, model derivative, viewers 7.star. So this is basically the way to bring in for viewer specific client-side assets, right? So 7.star, the latest version, major version of the viewer is 7. So 7.star means take the latest 7. Something latest version that is available currently, right? And bring the CSS style, because the viewer itself may need some custom CSS styling for the toolbar, for the panels and things like that. And we're also bringing in the JavaScript code for the viewer. So it's coming from the same domain, right? 7.star, and it's called typically the file that contains the viewer code is called viewer3d.js. You can also find another one called viewer3d.min.js. This is the same one, but minified, where all the names of functions and variables are shortened as much as possible so that you can reduce the overall file size, and code comments are removed and things like that. This one is better for debugging, right? Because if you simply include viewer3d.js, that means that the original source code inside of for the viewer itself remains, clean, not mangled. And you can step into the code of the viewer itself when debugging the client side, any client side issues or behavior. And then, what we do is we just set up a simple header that's just going to be the strip at the top where we show, a logo, maybe some title, and the drop down and the upload button, right? So that's just going to be a little bit of UI for the interaction with the application. And then the rest is really going to be preview as the rest of the page that's going to be occupied by the viewer itself. And an overlay is an HTML div that's going to be sitting on top of the viewer. And that's where we're going to show or hide the notifications. That's pretty much it. And then we include our own styling and our own application code, right? This is the main.js file. And we have to specify that this is a module, not a standard JavaScript file, but an ECMAScript 6 module, because we're using the import and export keywords there. So we have to explicitly inform the browser that this is an E6 module. Now we're also including a PNG logo. So we may need to grab that from somewhere. And I think when you go to the tutorials, we do mention it somewhere in there. Oh, yeah, we are. So I'll show you right away. So this is the basic markup for our single page application, right? And the final piece is the CSS styling. So again, we're going to have a file in our www root folder called main.css. And let me tell you what it does. So in www root, create a file called main.css, paste the content from the tutorial, and let's see what we're doing here. We're basically setting up some basic styling for the body of the HTML page itself so that there is no margin or padding, so that it occupies the entire area of the browser tab. It's using an artifact element font family. This is just something, this is a font type that is added automatically by the viewer CSS. So we're enabling it for our entire page so that the entire web application is using the same font as the viewer. And here we just set all the different elements, the divs, to be absolute position, meaning that we're going to control their exact position and size ourselves. So we're setting all their width to be 100% of the window or the browser tab, really. And then the header, we just hard code the height to 3EM so that it has a hard coded height. We use flex for display so that everything inside that header is nicely automatically aligned using the flex display method in CSS. And similar things in the rest here. We're just specifying dimensions and positions of the individual. So the preview and overlay, these two div elements are all sitting below the header, and they're covering the rest of the real estate. And the overlay div, it has an increased Z index so that it sits on top of the canvas. It's hidden by default. It has a display set to none, right? And it has like a semi-transparent black background so that it can sort of like dim the underlying viewer if we want to show a notification. And yeah, I think that's pretty much it. This is just a standard, again, sizing and flex display setup. All right, and that's it. Now, again, like as I mentioned earlier, you can see that we're in the header at the top. We're including some sort of a logo, which we don't really have here currently. So this could be causing some issues right now. So to show something in the header, you can just grab a PNG image from somewhere. And I think in the tutorial under the CSS snippet, you will actually see two links to grab an icon for the page and as well as the logo, like a Forge logo, if you want to use it in your application. So what I'm going to do is I'm going to download this image. Now I'm going to have to go to temp Forge Bootcamp. Day 1, simple viewer, www root. I'm going to grab the logo PNG and maybe the browser icon. Oh, yeah, the page icon as well. All right. So now I have my page icon and logo PNG, right? So these will now be available in my HTML because, again, these are all sitting inside the www root folder. That means that whenever I make a request to localhost 8080/logo PNG, the first middleware in our Express app will try and see if that logo PNG exists in our www root folder. And since it will find it there, the request will automatically be responded to from here, and none of the other middlewares will execute, right? So this Express static middleware will automatically send the content of the logo PNG file back to the browser. And if the browser asks for something like, I don't know, like if it asks for main.js, right? Again, this middleware will try and see, well, is there a main.js file inside this folder? And yes, it will find it, so it will send it back to the browser immediately. That's how the static serving works. All right, let's give it a try. Run our app. Listening on port 8080. Let's go to port 8080. And now, if we don't include any custom URL, the Express server will basically try and see if there is maybe an index HTML, because that's considered to be the default page, right? So it'll try and see if there is an index HTML in our static file folder, and it'll find it, right? So this is the small header that we included in our HTML. This is the dropdown that is automatically populated with all the files in our bucket. And this is the upload button we can use to initialize the upload process of a selected design. Now, what's happening here is that, see, we only have one model. That's the RVT file that I tried uploading to my bucket earlier using the VS Code extension, right? And when it gets selected, by the way, notice that after selecting the file, the URN of this Revit file was automatically appended as the hash URN here, right? As the hash fragment. So that means that if we were to take this link and share it with someone, they would not only see our application, but the app would immediately start loading this specific URN into the viewer as well. But what's happening now is that it says model has not been translated, right? What does that mean? Now, let me open the DevTools in the browser. You're going to be working with these a lot. These are really helpful. If you don't know how to use these, if you're using any modern browser, whether it's Chrome, Firefox, Safari, or Edge, you'll always have a way to get something called, typically it's called DevTools, right? In Chrome, you can find it under More Tools, Developer Tools. That's what I just enabled here. Here we have different ways to debug and work with your client-side Java's web application, right? You can investigate the different parts of your HTML, see what styling is applied to it. You can modify the styles. You can modify the markup itself as well, right? So now if I look at, for example, if I inspect the dropdown, I see that there's a single option, right, that we generated programmatically after receiving the list of files in our bucket. So I could maybe modify this and change the actual HTML markup. I can also, interact with the JavaScript on this page through this console. I can check any warnings or errors that maybe our application is outputting here. You can also work with the JavaScript code, right? So these are the two JavaScript files we've implemented. Viewer.js are the helper functions for initializing the viewer and loading models into it. And main.js is the application logic, right? Where we set up the dropdown, the upload, and everything. Now, why do we see model has not been translated? If you remember, what happened in the previous session is I used the VS Code extension to upload a file, but I did not translate it, right? So now when my app tries to query the status of whatever is selected in the dropdown, there is the model derivative service in Forge does not have any manifest for it, right? Because we haven't initialized any translation. So that's basically, let's see, we can actually check it here. So if I reload my page, now the dropdown has been populated, and now the app somebody is calling this onModel selected function that we implemented, right? So now what we're doing is, okay, let's try and get the status of this URN, because somebody is trying to load this Revit file, right? So we request a response, and the response looks like this. It says status not available. If you remember, this is the JSON that we are sending from our server side because we haven't found any manifest for this URN. So that's why we say model has not been translated, right? This should not happen. This only happened because, again, I uploaded the file by hand and I did not translate it. Maybe what we could do, maybe we could add a button here saying something like, restart translation or something like that. But for now, to keep things simple, what I'm going to do is, since I messed it up here in the first place, but by uploading a file separately, not through the application, I'm going to go back to my extension right-click the Revit file, and I'm going to say translate object. Because again, under the hood, what this does is nothing else than making a request to the model derivative service saying, hey, please start extracting information from this particular Revit file. So if I refresh the tree, you can now see that the Visual Studio Code extension is already reporting the translation to be in progress. And certain file formats in Forge can even report the percentage, the progress, like how far the translation has gotten. So we can wait for a little bit. 2%, okay. And maybe in the meantime, what we can do is we can, well, maybe let's wait. Looks like it's going pretty fast. Let's see if there are any questions in the meantime. Nope, it looks like we're good. Hopefully that's the reason. All right, so let's see, 65%. Mm-hmm. 74, 82. Now again, depending on the complexity of your design and maybe, you know, when you spike lows in Forge, maybe you get a lot of requests for a specific file translation. It may take a while. As you can see here, it took a couple of, well, maybe a minute or less than a minute, maybe half a minute. So as you can see, now Forge was able to extract a couple of 2D drawings. These are the A001, A102, A103. These are 2D sheets from that Revit file, and it also found a single 3D view. Now, again, you can right-click and preview these directly inside Visual Studio Code through the extension. But now, since that manifest is already available, you can even see it by right-clicking on the Revit file and try the view object manifest JSON. This is basically the JSON that our application will try and request from the Forge model derivative service to find out whether everything is already translated and how many derivatives are available, things like that, right? So this is the derivatives children, if you remember in the server-side code, that we're going through to find all the potential messages or error messages or warning messages. Here, let me just collapse the derivatives here. You can see that now it's already reporting status success and progress complete, right? So this means that this Revit file has now been completely and successfully converted and extracted for viewing in the viewer. And we can also look inside the children. So here you can see that Forge extracted different types of information. It extracted like a 3D view, a database with different properties from your design, and what else? A 2D sheet, right? And many different 2D sheets. So all that information is captured here, like you know, what types of assets these are, how big they are. So this is the information that the viewer then uses to load the corresponding data for viewing. Cool. So now, with our first model translated, we can go back to our application and reload. All right, so we can try get the status again. And now, let's see, the status says status success, progress complete, no messages, right? So this is basically an indication from our server to our client saying, yes, this file is ready. You can start loading it into the viewer. And that's basically what's going to happen. We clear notifications and we jump into the load model helper function, where we call the Autodesk viewing document load. This loads the manifest and it starts loading the default derivative, which is the 3D view. There it is. All right. And now let's see if our upload is working as well. I'm going to switch to the network tab, which is useful to monitor any kind of requests coming, any kind of communication between your client side and the server side. That's all captured in this network tab. So what I'm going to do is I'm going to hit the upload button. So now again, if you remember under the hood, what this did is it clicked on a hidden HTML input element to actually trigger this dialog to pop up, allowing us to select a file. So let's say I'm going to go to some of my sample files. So many of these can be found online. I have a bunch of AutoCAD sample drawing files here. So I'm going to grab maybe the architectural. I'm going to say open, and it will initiate the process of uploading the file to the server. See, so now we're showing notification saying, file has been uploaded, do not reload the page. And now it actually, in our code, if you remember in client side, when a file upload finishes, we immediately change this hash fragment asking the viewer to load that new file. But a new file hasn't been translated yet. That's why we saw translation in progress. Now, as you can see, the translation of this DWG file was really fast. So the notification was only showed up for a couple of seconds. And now we're already looking at this new architectural DWG file that I just uploaded. And now we should see, and we do see, two files in the dropdown, because now our bucket, we can go back to our VS Code extension and refresh this tree view. So we can see we now have two files that have been uploaded to our bucket. One I uploaded myself manually using the extension, and this other DWG file was uploaded through our new application. And it works. So see now, and we can again check this link. Of course, I mean, not a link to localhost, right? That would not work on other machines. But eventually, when we, let's say, deploy this application to somewhere, to AWS or Azure or Azure, Heroku, we can have a publicly visible URL with our application running on it, and we can share this type of link with our customers or our colleagues or anyone, and they'll be able to see our designs and preview them right away, and in their browsers on their PCs or laptops or phones, even on smartphones. And they'll be able to use the standard built-in functionality in the viewer, things like exploring the logical hierarchy of the individual designs, or reading properties that are available on the individual design elements. So that is our simple viewer application. That concludes our tutorial today. All right, yeah, so I think that's it. And now what we'll do is we'll have a last sort of a break. So it's going to be, I'm going to be around for 30 minutes more, just in case you guys have any final questions or any problems that you need to need my help unblocking. That's pretty much it. So to wrap up, this was our first topic of the week, a simple viewer. And in the rest of the week, we'll be covering different tutorials, different topics. Hub's browser, as I also mentioned earlier, is going to be a similar app as the one we built today, but that one will be centered around three-legged authentication, meaning that we will not be dealing with file upload and translations. Instead, we will allow the users of our application to log into the app with their own Autodesk credentials, and we will let them see their own content from other products such as BIM 360 or Autodesk Construction Cloud within our app. Then on Wednesday, we're going to be focusing purely on the client side, on the viewer. We're going to take any of your applications that you built Monday or Tuesday, and we're going to start extending the viewer itself so that you can do more things. You can add custom UI, custom panels, color things, differently and query different information from the model that's loaded in the viewer, all that stuff. That's going to be the topic for Wednesday. Focus on building, basically extracting information from your models and displaying them in different ways as dashboards or charts, pie charts and bar charts. And then on Thursday, the final day of the event, we're going to be looking at configurators. That's where we're going to be using the Forge design automation service that you can use to actually not just show and examine designs in the browser, but also to modify or create completely new designs remotely without having to have AutoCAD or Revit or Inventor installed on your machine. That's pretty exciting as well. So that's going to be covered on Thursday. Now, where to take it from here? So we assume again that you're new to Forge, that you've joined us this week to learn about what's possible. Now, if you are intrigued and interested in continue your work with the Autodesk Forge platform, one of the questions you may have is where to get more information, where to get additional support, right? For that, I would recommend two channels. We are very active on Stack Overflow. So if you ask any questions there, especially if you use any of these tags here, so at Autodesk-Forge for general Forge questions or Autodesk-Viewer for viewer-specific questions, we're going to get notified. We have a centralized system where we get tickets and questions from different channels, including Stack Overflow, and myself or one of my colleagues can hop on Stack Overflow and answer there. So that's a good channel when you want to ask a general question that may be relevant to others, or that maybe is, that where it makes sense to share that type of question. Then if you have maybe something that's more a question is more specific to your custom workflow, or maybe something that you don't want to share publicly on Stack Overflow, you can also go to the dev portal. That's the forge.autodesk.com, and you'll find in the support section a link to get help, and that'll basically that you're going to get to a form that you can use to submit your questions to us directly through an email, and then we can get back to you individually as well. All right, and then what's going to happen after the event? As I also mentioned a couple of times, we're going to be sending out a wrap-up email with links to the YouTube with the different recordings of all these sessions this week. If you're interested, we're also going to include the slides that we are using this week. And really importantly, we're going to be sending a link to a survey where we would really, really like to get your feedback on this event, on the format of the event itself, on the content of the tutorials, on everything around, right? So that we can really improve and make these events even better in the future. And then finally, if you are looking maybe at other ways of improving your skills with Forge, we run other types of events and we have other types of content as well. Roughly every 2 months, we run a Forge Accelerator, which is a sort of a hackathon where we invite you to come with a prototype, some idea, something you would like to build using Forge. And you can basically join us for free, either virtually or hopefully later this year, we can go back to live events that we typically organize in different Autodesk offices around the world. And you can join us for a week, our developer advocacy team. And we go to that event with you for that 1 week. We sit down with you and we help you code your prototype there during that 1 week, right? So it's sort of like a live Stack Overflow version where if you have any questions, if you run into any problems, instead of sending us an email or posting a question on Stack Overflow, you can just turn to us because we're sitting right next to you and you can ask your question and we can help unblock you or provide you guidance. We also have some pre-recorded lightning talks about different features with the different Forge components that you might find interesting as well. And we also have a blog where we often post articles on some specific workflows and use cases, like somebody maybe is asking, okay, how can I bring point clouds how can I combine point clouds with my BIM model in Forge Viewer, right? So we have a blog post on that. So you can search through that, see if you can find some existing resources on some very specific workflows or features you would like to implement. And thinking, yes, that should be it. Yep. So with that, thank you for spending the time with me today. Thank you for sticking with me. And I'll be looking forward to seeing you all, hopefully, tomorrow and on Wednesday when I'm presenting for the EMEA audience as well. Thank you. And yeah, so I'll stop the sharing, and but I'll remain on the Zoom call for 30 more minutes, just in case you have any additional questions. So thank you.